we need to write these mixed numbers as improper fractions. So first, we have 1 and 1/5. That's a mixed number because we have a whole number and a fraction, and we need to change that to an improper fraction. With improper fractions, the numerator is larger than the denominator. So how can we change mixed numbers to improper fractions? Well, the denominator stays the same, so in our improper fraction, the denominator will still be 5. But then, to get the numerator, we need to multiply the whole number by the denominator, and then add the numerator. So 1 times 5 is 5, plus 1 is 6, so that's our numerator. And what we're really doing when we change a mixed number to an improper fraction is changing the whole into the denominator. So here, changing one whole into 5/5. That's why we do 1 times 5 to get 5, so there you can see the 5/5 here. And then we add the 1/5 that we had in our question to give us 6/5 in total. Now we have 2 and 5/6. Again, the denominator is going to stay the same, and we need to multiply the whole number by the denominator, so multiply 2 by 6 and then add 5. 2 times 6 is 12, and 12 plus 5 is 17, so that's our numerator. And you can see why this works, because here we have 2 wholes, but if we change those 2 wholes into 6ths, then what was 2 wholes is now 12/6, and that's why we multiply 2 by 6 to get 12. Then we need to add the 5/6 that we had in our question, and that gives us 17/6 altogether. Finally, we have 3 and 5/8. Again, the denominator stays the same, and this time we need to multiply 3 by 8, so multiply our whole number by our denominator, and then we can add the numerator. So 3 times 8 is 24, and if we add the 5 from our numerator, that gives us 29 as the numerator of our improper fraction. And again, we can see why this works, because in 3 and 5/8 we have 3 wholes. But if we split those 3 wholes into 8ths, that gives us 8, 16, 24/8. And if we add the 5/8 that was in our question, that gives us 29/8 altogether. So that's why we multiply the whole number by the denominator and then add the numerator. Now we need to write these improper fractions as mixed numbers. So remember, an improper fraction is a fraction with a larger numerator than denominator. So here we have 8/5, or 8/5. Now a mixed number is a whole number and a fraction. Now, to change an improper fraction to a mixed number, the first thing to remember is that the denominator of the fraction in the mixed number will be the same as the denominator in the improper fraction. Now, we need to divide 8 by 5, because remember, a fraction is really a division. So 8 divided by 5, if we divide the numerator by the denominator, that gives us 1 remainder 3. That's because 1 times 5 is 5, and then we need 3 more to get to 8. So our whole number is 1, that's the number we get from our division, and then the remainder we get from the division we write as the numerator. So 8/5 is equal to 1 and 3/5 as a mixed number. So here we can see 8/5. We have fraction bars split into 5 pieces, so each of these pieces is 1/5, and we have 8 of them. Now what we're doing, when we change it back into a mixed number, we're making one whole, so now we don't have our one whole split into fifths, so we have 1 whole and 3 fifths. Now we have 11 over 3, or 11 thirds. Remember, the denominator of our mixed number will stay the same, and then we can divide the numerator by the denominator, so divide 11 by 3 to get our whole number and our numerator. So 11 divided by 3 is 3 remainder 2. That's because 3 times 3 is 9, and then from 9 we need 2 more to get to 11. So our mixed number is 3 and 2 thirds. Here we have the whole number, and then the remainder is the numerator. And again, we can see why this works. Here we have 11 thirds, because each of our fraction bar is split into 3 pieces, and we have 11 pieces altogether. Now all we're doing when we change it to a mixed number is making 3 wholes. So that gives us 3 wholes and then 2 thirds, so that's our mixed number. Now we have 21 over 8, or 21 eighths. Again, the denominator stays the same, and we need to divide 21 by 8. That's 2 remainder 5, because 2 times 8 is 16, but then from 16 we need 5 more to get to 21. So our mixed number is 2 and 5 eighths, because there's the whole number and then the remainder is the numerator. And again, we can show 21 eighths, because each of these fraction bar has been split into 8 pieces, and we have 21 pieces altogether. So why do we divide 21 by 8? Well, dividing by 8 means that we get 2 remainder 5, because we've now made 2 whole bars, but we have 5 eighths of this bar remaining, so that's 2 and 5 eighths. So here we're adding fractions with the same denominator, but we have 2 answer boxes. That's because we can write our answer to these questions as both an improper fraction and a mixed number. So first we have 4 fifths, so 4 parts out of 5 on our fraction bar, and we're adding 2 fifths, so that's 2 parts out of 5. You can see that adding is putting things together, and altogether we have 6 fifths, because each of these is 1 fifth, and we have 6 parts. Now what we can do is push these parts together, and that gives us 1 whole fraction bar shaded, and then 1 fifth of another one. So as a mixed number, 6 fifths is 1 and 1 fifth. That's because 6 divided by 5 is 1 remainder 1, or because 1 times 5 is 5, plus 1 is 6, and that's our numerator. Next we have 3 quarters, so 3 parts out of 4, and we're adding 3 quarters. Now, as an improper fraction, our answer is 6 quarters, because remember, each of these pieces is 1 quarter, and we have a total of 6 pieces. But again, we can push what we have together, and that makes 1 whole and 2 quarters, so that's our mixed number. And we can get that answer because 6 divided by 4 is 1 remainder 2, or because 1 times 4 is 4, and then we need 2 more to get 6, and that's the numerator of our improper fraction. Now 7 eighths, so 7 parts out of 8, and we're adding 5 eighths. That gives us 12 eighths altogether, because remember, when we add fractions with a common denominator, the denominator stays the same in our answer, and we just add the numerators. And you can see that each of these pieces is 1/8, and we have 12 pieces altogether. But what is 12 eighths as a mixed number? Well, if we combine to make 1 whole, that gives us 1 and 4 eighths, and that's because 12 divided by 8 is 1 remainder 4, because 1 times 8 is 8, and then we need 4 more to get to 12. Finally, we have 2 sixths plus 5 sixths. That's 7 sixths altogether, because the denominator stays the same and we just add the numerators, and because each of these pieces is 1 sixth, and altogether we have 7 pieces. Again, we can change it to a mixed number, because if we group to make one whole, that gives us 1 and 1 sixth as our mixed number. And that makes sense, because 7 divided by 6 is 1 remainder 1, and the denominator of a mixed number is always the same as the denominator of the improper fraction. Now for these questions, we need to subtract a fraction from a mixed number with one whole. So first, we have 1 and 3 fifths, and we need to subtract 4 fifths. But we have a problem here. We only have 3 fifths in our mixed number, but we want to take 4 fifths away. So what we need to do is to change our mixed number to an improper fraction. So as an improper fraction, 1 and 3 fifths is 8 fifths. That's because 1 times 5 is 5, and then if we add the numerator, 5 plus 3 is 8. So now we can subtract 4 fifths. Remember, when we subtract fractions, the denominator stays the same in our answer, and 8 minus 4 is 4. So our answer is 4 fifths. Now we have 1 and 2 sevenths, but we need to take 5 sevenths away. So we need to turn this mixed number into an improper fraction. 1 times 7 is 7, plus 2 is 9, and the denominator stays the same when we change it from a mixed number to an improper fraction. So now we found that 1 and 2 sevenths is the same as 9 sevenths, so we can subtract our 5 sevenths. The denominator stays the same, and 9 minus 5 is 4, so our answer is 4 sevenths. Now 1 and 1 quarter minus 3 quarters. Again, we need to change 1 and 1 quarter to an improper fraction. 1 times 4 is 4, plus 1 is 5, and the denominator stays the same. So now we can subtract 3 quarters. The denominator stays the same in our answer. 5 minus 3 is 2, so that's 2 quarters. And finally, 1 and 1/3 minus 2/3. So we can change 1 and 1/3 to 4/3. 1 times 3 is 3, plus 1 is 4. So now, when we take 2/3 away, we get 2/3 as our answer. And let's see what was happening here. So first, we started with 1 and 3 fifths, but we needed to take 4 fifths away. So what we did was really to change our 1 whole into fifths. That's why 1 and 3 fifths as an improper fraction is 8 fifths, because now you can see that each of these parts is a fifth, and we have 8 parts altogether. So now we can subtract 1, 2, 3, 4 fifths to give 4 fifths, what's left, as our answer. Then we had 1 and 2 sevenths, but we needed to take 5 sevenths away. So instead of 1 and 2 sevenths, we thought of that as being 9 sevenths. So we haven't changed the fraction, we haven't changed what's shaded at least, but we've represented the fraction in a way so that we can take 5 sevenths away. And if we subtract 1, 2, 3, 4, 5 sevenths, you can see that we now have 4 sevenths left. Then we had 1 and 1 quarter. We changed that to an improper fraction so that we could take 1, 2, 3 quarters away to give us 2 quarters as our answer. And finally, we had 1 and 1/3. but we needed to take 2/3 away. And to do that, we needed to split our 1 whole into thirds as well. So we had 4/3. Then we subtracted 2 of those thirds to give us 2/3 as our answer. So here we've got some missing fraction, addition and subtraction problems. And although these are fraction problems, we do the same thing that we do with missing numbers for whole numbers to find our missing number or our missing fraction. So first, 1 and 1/5 minus something equals 2/5. So here it's the second number in our subtraction or the subtrahend that's missing. So when the subtrahend is missing, we still use subtraction to find our missing number. So we need to work out 1 and 1/5 minus 2/5, and that will give us our missing fraction. But if we only have 1/5, we can't take 2/5 away. So we need to change 1 and 1/5 to an improper fraction. That's 6/5, because 1 times 5 is 5, plus 1 is 6, and the denominator stays the same. So now we can subtract 2/5, the denominator stays the same, and 6 minus 2 is 4. So our missing fraction is 4/5. Now something minus 3/7 equals 5/7. So this time it's the first number or the minuend of our subtraction that's missing. So remember, subtraction problems can be read backwards as addition problems. So to find our missing fraction, we need to add 5/7 and 3/7. When we're adding fractions, we keep the denominator the same, and 5 plus 3 is 8. So as an improper fraction, our answer is 8/7. But we can turn that back into a mixed number by dividing. 8 divided by 7 is 1 remainder 1. So our fraction is 1 and 1/7, because 1 times 7 is 7, plus 1 is 8, and the denominator stays the same. Now something plus 5/6 equals 1 and 3/6. So whenever we have a missing number in an addition problem, we always use subtraction to find our missing number. So we need to work out 1 and 3/6 minus 5/6 to find our missing fraction. But we only have 3/6 and we need to take 5/6 away. So let's change this mixed number into an improper fraction. 1 times 6 is 6, plus 3 is 9. So as an improper fraction, we have 9/6 because the denominator stays the same. So now we can subtract 5/6. The denominator is still 6, and 9 minus 5 is 4. So our missing number is 4/6. And we can show what we did here. So we knew that we started with 1 and 1/5. Then we subtracted something to get 2/5 as our answer. What did we subtract? Well, it's the 1, 2, 3, 4/5 that we can now see in blue on these fraction bars. Then we knew that 3/7 had been subtracted from something to leave 5/7. If we show the 3/7 that must have been subtracted in blue, we can see that the total at the start must have been 1 whole, because we have 1 whole fraction bar coloured in, and 1/7. Then, for this last question, we know that 1 and 3/6 was the answer, and 5/6 had been added. So we can show the 5/6 that must have been added in blue, which means we must have started with 4/6, so the 4/6 that are yellow here. Now for these questions, we're adding or subtracting whole numbers and fractions. So first, we have 3 plus 3/7. So that's 3 wholes and 3/7. So our answer is just 3 and 3/7. when we're adding a fraction to a whole number, we just get a mixed number with the whole number and the fraction next to each other. So adding a fraction to a whole number is fairly simple, but subtracting a fraction from a whole number is slightly trickier. So first, we have 1 minus 1/4. So we can show the 1 whole that we start with, but to subtract 1/4, we need to change this 1 whole into 4 quarters. So then, when we subtract 1/4, we get 3/4 as our answer, because 4 minus 1 is 3. So what is 1 minus 2/5? Again, we can show 1 whole, but to subtract 2/5, we need to split that 1 whole into 5/5. So when we take 2/5 away, that leaves us with 3/5 as our answer, because 5 minus 2 is 3, and the denominator of the fraction that we were subtracting stays the same. Now we have 4, so 4 wholes, and we need to subtract 7/8. Now to do that, we need to change one of our wholes into eighths. So now, rather than thinking of 4 as 4 wholes, we can think of it as 3 wholes and then 8/8. So now we can take 7/8 away, and that leaves us with 3 wholes and 1/8, so 3 and 1/8. Now we have 4, so 4 wholes, and we need to subtract 1/4. But again, we're going to need to change one of our wholes into 4 quarters in order to subtract. So we can think of 4 as being 3 wholes and 4 quarters. So now, when we subtract 1/4, we have 3 wholes and 3 quarters as our answer. And notice this question is quite similar to the question above. If we know that 1 minus 1/4 is 3 quarters, then we know that 4 minus 1/4 must be 3 and 3 quarters, because 4 is 3 more than 1. Finally, we have 3 minus 2/5, and again, you can see it's similar to the question above. With 3, we have 3 wholes, but to subtract 2/5, we need to change one of our wholes into 5/5, so we can think of the number 3 as being 2 wholes and 5/5. So now, when we take 2/5 away, we get 2 and 3/5 as our answer. Now for these questions, we're adding a fraction to a mixed number, and we can start by adding the fractions first. So when we add fractions, the denominator stays the same, and 3 plus 4 is 7. But we have 1 whole in the question. We're not adding any wholes, so we have 1 whole in our answer as well. Next, we have 2 and 2/5 plus 2/5. So we start by adding our fractions. We start by adding what's smaller. Just as when we're using column addition, we start by adding the smallest digits, or the digits in the smallest place value. So first, we need to add 2/5 plus 2/5. The denominator stays the same, and 2 plus 2 is 4. Then we look at our wholes. We have 2 wholes in our question. We're not adding any wholes, so there are 2 wholes in our answer as well. That's 2 and 4/5. Finally, we have 1 and 3/8 plus 4/8. We add the fractions first, and the reason why we add the fractions first is that if we get an improper fraction when we add the fractions, we'll need to change it back into a mixed number. But we'll look at that in the next video. For this question, we need to start by adding 3/8 and 4/8. The denominator stays the same, 3 plus 4 is 7, and then we can look, we have 1 whole in the question. We're not adding any wholes, so we have 1 whole in our answer. And to show what we did, first we started with 1 and 3/10, so 1 whole and 3/10, and we were adding 4/10. When we put what we have together, we get 1 7/10 as our answer. Then we had 2, so 2 wholes and 2/5, and we were adding 2/5. Put that together, and we got 2 4/5 as our answer. Then we had 1 3/8, and we were adding 4/8. So we put the 3/8 and the 4/8 together to get 7/8. That gave us 1 7/8 as our answer. Now here, we're still adding a fraction to a mixed number, but for these questions, we'll need to think really carefully about how we write our answer. So first, we have 1 2/3, and we're adding 1/3. We can start by adding the fractions in the question, so 2/3 plus 1/3. The denominator stays the same, and 2 plus 1 is 3. But we can't write 1 3/3 as our answer, because in a mixed number, we need a proper fraction. Now 3/3 is the same as 1 whole, because 3 divided by 3 is 1. So when we add the 1 whole that we've made from adding our fractions to the 1 whole that we started with in our question, that gives us our answer of 2. So our answer is just 2 wholes. So sometimes when we're adding a fraction to a mixed number, we can still get a whole number as our answer if the fractions add together to total 1 whole. Next, we have 2 3/5 plus 4/5. So we start by adding our fractions. The denominator stays the same, and 3 plus 4 is 7. So adding our fractions has given us 7/5, but we can't write 2 7/5 as our answer because we can't have an improper fraction in a mixed number. So we need to turn those 7/5 back into a mixed number. 7 divided by 5 is 1 remainder 2. So as a mixed number, 7/5 is 1 2/5. Because 1 times 5 is 5, plus 2 is 7, and that's the numerator of our improper fraction. But 1 2/5 is not our answer, because we've only added the fractions. So we need to add what we got from adding our fractions to the whole number in our question. Now 2 plus 1 is 3, and the 2/5 stays the same, so our answer is 3 2/5. Finally, we have 1 3/4 plus 3/4. So we can start by adding our fractions. That gives us 6/4, but 6/4 is an improper fraction, and we can't write 1 6/4 as our answer because we can never have an improper fraction in a mixed number. But we can change 6/4 into a mixed number because 6 divided by 4 is 1 remainder 2. The denominator stays the same, so as a mixed number, we have 1 2/4. But that's not our answer, because again, we've only added the fractions, and we have 1 whole in our question. So we need to add what we got from adding our fractions to the 1 whole that we had in our question, and that gives us 2 2/4 as our answer. And we can see what we were doing here. So for this first question, we started with 1 2/3, and we were adding 1/3. But when we added our fractions, we got 3/3, and 3/3 is the same as 1 whole. So putting that together with the 1 whole that we started with in our question gave us 2 wholes as our answer. Then we had 2 3/5, and we were adding 4/5. Now when we added our fractions, that gave us 7/5. But we can't write 2 7/5 as our answer because we can't have an improper fraction in a mixed number. So instead of 7/5, we needed to change that to 1 whole and 2/5. Putting the 1 and 2/5 together with the 2 wholes that we started with in our question gave us our answer 3 wholes and 2/5. Finally, we had 1 and 3/4, and we were adding 3/4. Adding our fractions together gave us 6/4, but we couldn't write 1 and 6/4, so we changed the 6/4 into 1 whole and 2/4. Putting the 1 and 2/4 together with the 1 whole that we started with in our question gave us our answer 2 and 2/4. Now we're adding a fraction to a mixed number, but this time we're going to get our answer by first changing the mixed number into an improper fraction. So first we have 1 and 2/3 plus 1/3. 1 times 3 is 3, plus 2 is 5, so that's our numerator, and the denominator stays the same. So 1 and 2/3 is 5/3 as an improper fraction. So now we can add the 1/3. Remember, when we add fractions, the denominator stays the same, and 5 plus 1 is 6. So we get 6/3. Now 6 divided by 3 is exactly 2 with no remainder. So our answer is 2 wholes. Next, we have 2 and 3/5, and we're adding 4/5. We can change 2 and 3/5 into an improper fraction. 2 times 5 is 10, and then 10 plus 3 is 13. So that's our numerator, and the denominator stays the same. Now we can add 4/5. The denominator stays the same in our answer, and 13 plus 4 is 17. So as an improper fraction, our answer is 17/5, but we can change that back into a mixed number by dividing. 17 divided by 5 is 3, remainder 2, because 3 times 5 is 15, plus 2 is 17. The denominator stays the same, so our answer as a mixed number is 3 and 2/5. Finally, we have 1 and 3/4 plus 3/4. So we can change 1 and 3/4 into an improper fraction by multiplying the whole number by the denominator and then adding the numerator. So 1 times 4 is 4, plus 3 is 7. The denominator stays the same when we change it to an improper fraction, so we have 7/4. We can add 3/4 to that. The denominator stays the same, and 7 plus 3 is 10. So as an improper fraction, our answer is 10/4, or 10 over 4. But we can change that back into a mixed number by dividing. 10 divided by 4 is 2, remainder 2, because 2 times 4 is 8, and then we need 2 more to get to 10. The denominator stays the same in our answer, so that's 2 and 2/4. So let's see what we did here. For this first question, we had 1 and 2/3, and we were adding 1/3. We changed 1 and 2/3 into an improper fraction, so that's 5/3. When we add 1/3 to that, we get 6/3 as our answer, but 6/3 is the same as 2 wholes. You can see that we now have 2 whole fraction bars shaded. Next, we had 2 and 3/5, and we were adding 4/5. First, we changed 2 and 3/5 into an improper fraction. That's 13/5, because if we change our 2 wholes into fifths, that gives us 10/5, and then we add the 3/5 that we had in our mixed number to begin with. Now, if we put that together, that gives us 17/5. Remember, each of these little pieces is 1/5, and we have 17/5 altogether. But we can change that back into a mixed number, because if we divide 17 by 5, that gives us 3 remainder 2, so 3 wholes and 2 fifths as our answer. Finally, we had 1 and 3 quarters, and we were adding 3 quarters. We changed 1 and 3 quarters into 7 quarters. Remember, each of these pieces is a quarter, and we have 7 of them here, and if we add the 3 of them that we have here, the 3 of them that we're adding, that gives us 10 quarters altogether. But we can change that back into a mixed number by dividing. 10 divided by 4 is 2 remainder 2, so that's 2 wholes and 2 quarters as our answer. Now we need to add mixed numbers. So first we have 2 and 3 fifths, and we're adding 2 and 1 fifth. We can start by adding our fractions together, so working out 3 fifths plus 1 fifth. Remember, when we add fractions, the denominator stays the same, and 3 plus 1 is 4. But now we need to add our whole numbers. 2 plus 2 is 4, so our answer is 4 and 4 fifths. Next, we have 3 and 4 sevenths plus 1 and 1 seventh. We can start by adding our fractions together. The denominator stays the same in our answer, and 4 plus 1 is 5. Then we can add our whole number. So 3 plus 1 is 4, and that gives us our answer, 4 and 5 sevenths. To show what we were doing here, we started with 2 and 3 fifths, so that's 2 wholes and 3 parts out of 5 of another fraction bar, and we were adding 2 and 1 fifth. We started by adding our fractions, and when we put them together, we can see that we have 4 fifths. Then we added our wholes, and 2 plus 2 is 4, so that was the whole number of our mixed number answer. Then we had 3 and 4 sevenths, so 3 whole fraction bars and 4 parts out of 7, and we were adding 1 and 1 seventh. We started by adding the 4 seventh and the 1 seventh to give us 5 sevenths. Then we added the 1 whole to the 3 wholes that we started with to give us 4 and 5 sevenths as our answer. And you can see that we have 4 whole fraction bars and 5 sevenths of another one. Here we're adding mixed numbers. So first we have 2 and 4 fifths plus 2 and 2 fifths. If we add 4 fifths and 2 fifths, we get 6 fifths as our fraction, because when we add fractions, the denominators stay the same. But 6 fifths is an improper fraction, so we're going to need to do something slightly different here. Adding our whole numbers, 2 plus 2 is 4. So we can write 4 plus 6 fifths, because when we add our whole numbers, we get 4, and when we add our fractions, we get 6 fifths. But we can't write 4 and 6 fifths as our answer, because we can't have an improper fraction in a mixed number. We can't have a fraction where the numerator, or top number, is larger than the denominator. So what we need to do is change those 6 fifths back into a mixed number. That's 1 and 1 fifth, because 6 divided by 5 is 1 remainder 1, or because 1 times 5 is 5, plus 1 is 6, and that's the numerator of our improper fraction. So 4 plus 1 is 5, the 1 fifth stays the same, so our answer is 5 and 1 fifth. Now we have 2 and 3 quarters, and we're adding 1 and 3 quarters. If we add the fractions together, 3 quarters plus 3 quarters is 6 quarters, but that's an improper fraction, so we'll know that we're going to need to change it back into a mixed number, and then add that to our whole numbers. So 2 plus 1 is 3, And 3/4 plus 3/4 is 6/4, because remember, when we add fractions, the denominator stays the same. But again, we can't write 3 and 6/4 as our answer, because we can't have an improper fraction in a mixed number. We need to change 6/4 back into a mixed number. So 6 divided by 4 is 1 remainder 2. So 6/4 is 1 and 2/4 as a mixed number. And that makes sense because 1 times 4 is 4, plus 2 is 6, and that's the numerator of the improper fraction we had. So adding that to our 3 wholes, 3 plus 1 is 4, the 2/4 stays the same, so our answer is 4 and 2/4. So why is it that the whole numbers in our question were 2 and 1, but the whole number in our answer was 4? Well, that's because we made another whole number by changing the improper fraction into a mixed number. We can see that more clearly if we show the fraction bars. So first, we had 2 and 4/5, so 2 wholes and 4/5 of another fraction bar, and we were adding 2 and 2/5. When we added the fractions together, we got 6/5, but we had to change that back into a mixed number, so that's 1 whole and 1/5. When you add 1 and 1/5 to the 4 wholes that we got from adding the whole numbers in our question, that gives us our answer 5 and 1/5, and you can see that on our fraction bars we now have 5 wholes and 1/5. Then we had 2 and 3/4, so that's 2 wholes and 3/4, and we were adding 1 and 3/4. When we put the quarters together, we got 6/4, but we knew that we couldn't write 3 and 6/4 as our answer. Instead, we needed to change 4 of those quarters into 1 more whole. So adding the fractions, what we have at the bottom, gave us 1 and 2/4. When we add that to the 3 wholes that we have from adding the whole numbers in our question, that gave us our answer 4 and 2/4. And you can see that we now have 4 whole fraction bars and 2/4 of another one. Now here we're adding mixed numbers, but this time we're going to get our answer by changing both of our mixed numbers into improper fractions. So first we have 2 and 4/5 plus 2 and 2/5. We can change 2 and 4/5 into an improper fraction. 2 times 5 is 10, plus 4 is 14. So that's 14/5 as an improper fraction, because the denominator stays the same. And we need to add 2 and 2/5, but we can change that to an improper fraction as well. 2 times 5 is 10, plus 2 is 12, so that's 12/5 as an improper fraction. Now, we know that when we add fractions, the denominator stays the same in our answer. And 14 plus 12 is 26. So as an improper fraction, our answer is 26 over 5, or 26/5. But we can change that back into a mixed number by dividing. 26 divided by 5 is 5 remainder 1. So our answer is 5 and 1/5, because 5 times 5 is 25, and then we need 1 more to get to 26, so to get to the numerator of our improper fraction. Now we have 2 and 3/4 plus 1 and 3/4. As an improper fraction, 2 and 3/4 is 11/4, because 2 times 4 is 8, and then 8 plus 3 is 11. We're adding 1 and 3/4, so that's 7/4 as an improper fraction, because 1 times 4 is 4, plus 3 is 7. When we add fractions, even improper fractions, the denominator always stays the same in our answer. 11 plus 7 is 18, so as an improper fraction, our answer is 18 over 4, or 18 quarters. But we can change improper fractions back into mixed numbers by dividing. 18 divided by 4 is 4 remainder 2. That's because 4 times 4 is 16, and then we need 2 more to get to 18. So our answer is 4 and 2 quarters. So now let's show fraction bars to understand what we did. For this first question, we had 2 and 4 fifths, so that's 2 wholes and 4 fifths, and we were adding 2 and 2 fifths. We changed both numbers into improper fractions, so that gave us 14 fifths and 12 fifths. Putting that together, we got 26 fifths, because remember, each of these parts is 1 fifth, and we have 26 of them. But to change that back into a mixed number, we divided 26 by 5, and that gave us 5 wholes and 1 fifth as our answer. Then we had 2 and 3 quarters, so 2 wholes and 3 quarters, and we were adding 1 and 3 quarters. We changed both numbers into improper fractions, so we had 11 quarters plus 7 quarters. Putting that together gave us 18 quarters altogether, because remember, each of these parts is 1 quarter, and we have 18 parts altogether. But when we change that from an improper fraction into a mixed number, we got 4 wholes and 2 quarters as our answer. Now we need to subtract a fraction from a mixed number. So first we have 1 and 9 tenths minus 4 tenths. So first, let's see if we can subtract 4 tenths from 9 tenths. Remember, when we subtract fractions, the denominator stays the same, and 9 minus 4 is 5. So our fraction is 5 tenths. But in our question, we start with 1 whole. We're not taking any wholes away, so we still have that 1 whole in our answer, 1 and 5 tenths. Next, 2 and 4 fifths minus 3 fifths. If we subtract 3 fifths from 4 fifths, we get 1 fifth as our fraction, because the denominator stays the same, 4 minus 3 is 1. But again, here we started with 2 wholes. We weren't subtracting any wholes, so we still have those 2 wholes in our answer. Finally, 1 and 5 eighths minus 3 eighths. When we subtract fractions, the denominator stays the same, and 5 minus 3 is 2. We still have our 1 whole, because we're not taking any wholes away, so that gives us our answer, 1 and 2 eighths. So we can show fraction bars to show what we did here. We started with 1 and 9 tenths, so that's 1 whole and 9 tenths, and we were subtracting 4 tenths. If we subtract 1, 2, 3, 4 tenths to show what we've subtracted in yellow, that leaves us with 1 whole and then 5 tenths of this fraction bar still in blue, so that's our answer, 1 and 5 tenths. Then we had 2 wholes and 4 fifths. We subtracted 1, 2, 3 fifths to get 2 and 1 fifth as our answer. Then we had 1 and 5 eighths. We subtracted 1, 2, 3 of those eighths to give us 1 whole and 2 eighths left in blue, so that's our answer. So here we're still subtracting a fraction from a mixed number, but this time we can't subtract the fraction from the fraction in the mixed number. So first we have 2 and 1/3, but we need to subtract 2/3, and there's only 1/3 in our mixed number. So what we can do is exchange with our whole number. So 1 less than 2 is 1, and that gives us 3 more thirds, so we can add the denominator to the numerator. 3 plus 1 is 4, so 1 and 4/3 is the same as 2 and 1/3. So now we can take 2/3 away. We still have our 1 whole, but 4/3 minus 2/3 is 2/3 because the denominator stays the same. So that gives us our answer. Next we have 3 and 1/5, and we need to subtract 4/5. But if we only have 1/5, we can't take 4/5 away. So we need to exchange one of our wholes for 5 more fifths. 1 less than 3 is 2, and that means we have 5 more fifths, so we can add the denominator to the numerator. 5 plus 1 is 6, so 2 and 6/5 is the same as 3 and 1/5. But now we can take 4/5 away. So 2 minus nothing is 2, and 6/5 minus 4/5 is 2/5. So our answer is 2 and 2/5. Finally, we start with 2 and 1/4, but we need to take 3/4 away. So we need to exchange with our whole number. 1 less than 2 is 1, and that means we can add the denominator to the numerator. So 1 and 5/4 is the same as 2 and 1/4. But now we can take our 3/4 away. We now have 1 whole, and 5/4 minus 3/4 is 2/4. So 1 and 2/4 is our answer. It's easier to understand what's happening here if we show the fraction bars. So for this first question, we had 2 and 1/3, so that's 2 wholes and 1/3, but we needed to take 2/3 away. So what we did is split one of our wholes into thirds. That gave us 1 whole and 4/3. So then we could take 2/3 away to give us 1 whole and 2/3 as our answer. So that's what's left in blue. Then we started with 3 wholes and 1/5, but we needed to take 4/5 away. So we changed one of our wholes into fifths. That meant we had 2 wholes and 6/5. So we could take away 1, 2, 3, 4/5, and that meant we were left with 2 wholes and 2/5 in blue, so that was our answer. Finally, we had 2 and 1/4, but we needed to take 3/4 away. We changed one of our wholes into quarters, and that meant we had 4 more quarters, so we could add the denominator to the numerator. That gave us 1 whole and 5/4, and you can see that we have 5/4 here because each of these pieces is 1/4, and we have 1, 2, 3, 4, 5 of them. So then we could subtract 1, 2, 3 of those quarters to leave us with 1 whole and 2/4 of this fraction bar shaded blue. So that's 1 and 2/4. Now we're subtracting a fraction from a mixed number, but this time we're going to get our answer by changing the mixed number into an improper fraction. So first we have 2 and 1/3, and we need to subtract 2/3. So first, to change 2 and 1/3 into an improper fraction, we multiply the whole number by the denominator and then add the numerator. 2 times 3 is 6, and then 6 plus 1 is 7. So the denominator of our improper fraction stays the same, and that means that 2 and 1/3 is the same as 7/3. So now we're subtracting 2/3. Remember, when we subtract fractions, the denominator always stays the same. And now 7 minus 2 is 5. So, as an improper fraction, our answer is 5/3. If we want to change that back into a mixed number, we can divide, and 5 divided by 3 is 1 remainder 2. That's because 1 times 3 is 3, and then we need 2 more to get to 5, and the denominator stays the same, so our answer is 1 and 2/3. Now we have 3 and 1/5, and we need to subtract 4/5. Again, we can change our mixed number into an improper fraction. 3 times 5 is 15, and 15 plus 1 is 16. The denominator of our improper fraction is the same as it was in the mixed number. So, as an improper fraction, 3 and 1/5 can be written as 16/5. So now we can take our 4/5 away. The denominator stays the same, and 16 minus 4 is 12. So our answer could be written as an improper fraction, so as 12/5. But if we want to change that back into a mixed number, we can divide 12 by 5. That's 2 remainder 2, because 2 times 5 is 10, and then we need 2 more to get to 12. Finally, we have 2 and 1/4, and we need to take 3/4 away. 2 times 4 is 8, plus 1 is 9, so 2 and 1/4 is the same as 9/4. We're subtracting 3/4, so the denominator stays the same, and 9 minus 3 is 6. So we could write 6/4 as our answer, but if we want to write our answer as a mixed number, 6 divided by 4 is 1 remainder 2, because 1 times 4 is 4, then we need 2 more to get to 6. So that gives us 1 and 2/4 as our answer. We can show fraction bars to see what we were doing here. So for this first question, we started with 2, so 2 wholes, and 1/3. We changed that into an improper fraction, and that gave us 7/3, because remember, each of these pieces is 1/3, and we have 7 of them altogether. We were taking 2/3 away, so if we subtract 1 2/3, which are now yellow, we can see what's left in blue is 5/3. And we can change that back into a mixed number, because 5 divided by 3 is 1 remainder 2, so that's 1 whole and 2/3. We can see 2/3, 2 parts out of 3 of this fraction bar are now blue. Then we had 3 and 1/5, so 3 wholes and 1/5. We needed to take 4/5 away, but first we changed those 3 wholes into 15/5, and adding the 1/5 that we had to start with gave us 16/5 altogether. We can subtract 1, 2, 3, 4 of those fifths, and now we have 12/5, so 12 of these fifths left in blue. We can change that back into a mixed number, and that's 2 and 2/5 as a mixed number. Finally, we had 2 wholes and 1/4. We changed that to 9/4 because we've got 8/4 in what were the 2 whole, plus the 1/4 that we started with gives us 9/4. We're subtracting 3/4, and if we subtract, that leaves us with 6 of these quarters left in blue. But 6/4 is the same as 1 and 2/4, because 6 divided by 4 is 1 remainder 2. So 1 and 2/4 was our answer if we're writing it as a mixed number. Now for these questions, we're subtracting mixed numbers. So first, we have 2 and 3/5 minus 1 and 1/5. When we're subtracting a mixed number, first we check to see if we can subtract the fraction from the fraction that we start with. And we can subtract 1/5 from 3/5. Remember, when we subtract fractions, the denominator stays the same, and 3 minus 1 is 2. So 2/5 is our fraction. But then we need to look at our whole numbers. We have 2 minus 1, so that's 1 in our answer, which gives us 1 and 2/5. Next, we have 3 and 5/7 minus 2 and 2/7. We check to see if we can subtract the fraction, and 5/7 minus 2/7 is 3/7, because the denominator stays the same, 5 minus 2 is 3. But then we need to subtract the whole numbers. 3 minus 2 is 1, so that gives us 1 3/7. We can show what we did using fraction bars. So we started with 2, so 2 wholes and 3/5. We were subtracting 1 1/5, but we subtracted the 1/5 first, then we subtracted the 1 whole. So you can see what's left in blue is 1 whole and then 2/5 of this fraction bar. So that's why our answer was 1 2/5. Next we had 3 5/7, so 3 wholes and 5 parts out of 7 of another fraction bar. We subtracted the fraction first, so we can subtract 1 2 of those sevenths to give us 3/7 of this fraction bar left in blue, and then we subtracted 2 wholes to leave us with just 1 whole, so our answer was 1 3/7. Now here we're subtracting a mixed number. So for this first question, we have 2 2/5 minus 1 4/5. When we're subtracting mixed numbers, we see if we can subtract the fraction first. But here we start with just 2/5 and we need to subtract 4/5. So what we need to do is exchange one of our wholes for 5 more fifths. So 1 less than 2 is 1, and that means that we can add the denominator to the numerator. 5 plus 2 is 7, so 1 7/5 is the same as 2 2/5. So now we can subtract 1 4/5. We subtract the fractions first, and 7/5 minus 4/5 is 3/5, because remember, we keep the denominator the same. And now, if we look at our whole numbers, because we've exchanged, we have 1 minus 1, so that's 0. So our answer is just 3/5. Next, we have 3 1/4, but we need to subtract 1 3/4. If we only start with 1/4, we can't take 3/4 away, so we need to exchange with one of our wholes. 1 less than 3 is 2, but that gives us 4 more quarters. So if we add the denominator to the numerator, 4 plus 1 is 5. So 2 5/4 is the same as 3 1/4, but now we can subtract 1 3/4. So if we subtract the fraction part first, the denominator stays the same in our answer, and 5 minus 3 is 2. Then we can subtract the whole number, and 2 minus 1 is 1, so our answer is 1 2/4. And we can show fraction bars to see what we did here. So we started with 2 2/5, so that's 2 wholes and 2/5. But when we looked at what we were subtracting, we saw that we needed to take 4/5 away. So we exchanged one of our wholes for 5 more fifths. That gave us 1 7/5. So then we could take away 1, 2, 3, 4 of those fifths to leave 3/5, and we were subtracting 1 whole, so that left us with just 3/5. Next we had 3 1/4, so 3 wholes and 1/4, but when we looked at what we were subtracting, we saw that we needed to subtract 3/4. So we had to exchange one of our wholes for 4 more quarters. That gave us 2 wholes and 5/4. So then we could take away 3/4 and then subtract the 1 whole to give us what's left in blue, which is 1 whole and 2/4. Now here we're subtracting mixed numbers, but this time we're going to subtract by changing both mixed numbers in the question into improper fractions. So first we have 2 2/5 minus 1 4/5. So we can change 2 2/5 into an improper fraction. 2 times 5 is 10, and then 10 plus 2 is 12. So as an improper fraction, 2 and 2/5 can be written as 12/5. And we can change 1 and 4/5 into an improper fraction as well. Remember, we multiply the whole number by the denominator, and 1 times 5 is 5, and then we add the numerator. 5 plus 4 is 9, so we're subtracting 9/5. So remember, when we subtract fractions, we keep the denominator the same in our answer. And now 12 minus 9 is 3, so our answer is 3/5. Next, we have 3 and 1/4 minus 1 and 3/4. So again, we can change both of these mixed numbers into improper fractions. 3 times 4 is 12, plus 1 is 13, and remember the denominator stays the same. We're subtracting 1 and 3/4, but we can change that into an improper fraction as well. 1 times 4 is 4, plus 3 is 7, so that's 7/4 as an improper fraction. Now we keep the denominator the same in our answer, and 13 minus 7 is 6, so as an improper fraction, our answer is 6/4, or 6/4. We can change that back into a mixed number by dividing 6 by 4, so dividing the numerator by the denominator. 6 divided by 4 is 1 remainder 2, so that's 1 and 2/4 as our answer. 1 times 4 is 4, and then we need 2 more to get to 6, so 6/4 is 1 and 2/4 as a mixed number. We can show fraction bars to see what we did here. So we started with 2 and 2/5, but that's 12/5 as an improper fraction. So when we subtracted 1 and 4/5, instead we could subtract 9 of those fifths to give us 3/5 as our answer. Then we had 3 and 1/4, so 3 wholes and 1/4, but we turned those wholes into quarters as well, because we changed 3 and 1/4 into an improper fraction. We were subtracting 1 and 3/4, but that's the same as 7/4, and if we subtract 7 of these quarters, we're left with 6/4. But as a mixed number, you can see that here we have one whole fraction bar shaded blue and 2/4 of another one, so that gives us our answer 1 and 2/4. Five thirds is equal or equivalent to how many ninths? So for these questions, we have improper fractions, but we can still find equivalent fractions in exactly the same way. Remember, we either use multiplication or division to find equivalent fractions, and here we can see that 3 times 3 is 9. What we do to the denominator, we need to do to the numerator as well, and 5 times 3 is 15. So 5 thirds is equivalent or has the same value as 15 ninths. Now 11/5 is equivalent to how many tenths? Well, 5 times 2 is 10. What we do to the denominator, we do to the numerator as well, and 11 times 2 is 22. So that's our numerator. Now we have 20 twelfths, and we need to find an equivalent fraction with a denominator of 3. So here, because the denominator is smaller than the denominator of the fraction that we started with, we know that we'll need to use division to find our equivalent fraction. Now 12 divided by 4 is 3. That's because 3 times 4 is 12. And again, what we do to the denominator, we need to do to the numerator. 20 divided by 4 is 5, because 5 times 4 is 20. So our missing numerator is 5. And we can see that though the numbers are different in the equivalent fractions, the fractions are the same size. So we can show 5/3 because remember, if we've got a whole fraction bar split into 3, then each of the pieces is 1/3, and we can see that we have 5 of them. But we can see that that's equivalent to 15/9, because if each of our fraction bar is split into 9 pieces, then we need 15 of those pieces to have the same amount shaded as we had with 5/3. For this middle question, 11/5 is the same as 22/10. If the fraction bar's been split into fifths, then we need 2 whole fraction bars and 1/5, and we can see that we have the same amount shaded if the fraction bar's been split into tenths, and we have 22 of those tenths. 20/12 is equivalent to 5/3. We can see that in both fractions, exactly the same amount is shaded in the fraction bars. So here we're comparing fractions which have different numerators and different denominators. But we know that it's easy to compare fractions if the denominators are the same. So we can use our knowledge of equivalent fractions to help us compare fractions. First, we have 3/4 and 7/8. Now 8 is in the 4 times table, so we can find a fraction equivalent to 3/4, which has a denominator of 8. Remember, we use multiplication or division to find equivalent fractions, and 4 times 2 is 8. What we do to the denominator, we need to do to the numerator as well, and 3 times 2 is 6. So, because we know that 3/4 is equivalent to 6/8, we know that it must be less than 7/8. Now we have 11/15 and 3/5. 15 is in the 5 times table, so here it's the second fraction that we need to find an equivalent fraction for. We need to find an equivalent fraction for 3/5, which has a denominator of 15. 5 times 3 is 15, and 3 times 3 is 9. So because we know that 3/5 is only equivalent to 9/15, we know that 11/15 must be larger. Now we have 2/3 and 7/12. 12 is in the 3 times table, so we can find an equivalent fraction to 2/3, which has a denominator of 12. 3 times 4 is 12, and 2 times 4 is 8. So, because 2/3 is equivalent to 8/12, we know that it must be larger than 7/12. So, let's use the fraction bars to see what we were doing. First, we had 3/4 and 7/8. We changed those 3/4 into 6/8, which meant that we could see that 3/4 was smaller than 7/8. Next, we had 11/15 and 3/5. We changed 3/5 into 9/15, so we could see that 11/15 was the larger fraction. Last, we had 2/3 and 7/12. We saw that 2/3 was equivalent to 8/12, so we knew that 2/3 must be the larger fraction. Now we're comparing improper fractions, and we know that to compare fractions, it's easier if the denominators are the same. So we can find equivalent fractions for our improper fractions. We're comparing 5/4 and 9/8. Now 8 is in the 4 times table, so we can find an equivalent fraction to 5/4, which has a denominator of 8. 4 times 2 is 8, and what we do to the denominator, we do to the numerator as well, and 5 times 2 is 10. So, because 5/4 is equivalent to 10/8, we know that it must be larger than 9/8. Now we're comparing 4/3 and 17/12. 12 is in the 3 times table, so we can find a fraction equivalent to 4/3 with a denominator of 12. 3 times 4 is 12, and 4 times 4 is 16. That's less than 17, so we know that 4/3 is less than 17/12 because 4/3 is only equivalent to 16/12. We can see what we were comparing with fraction bars. We had 5/4 and 9/8. We changed those 5/4 into 10/8 so we could see that it was larger. Then we had 4/3 and 17/12. We changed those 4/3 into 16/12 so we could see that 4/3 is less than 17/12. We have 7/10, 3/5, 13/20, and 3/4, and we need to order these fractions from smallest to largest. Now we know that to compare fractions, it's easier if the denominators are the same. The largest denominator we have here is 20, and 20 is in the 10 times table, it's in the 5 times table, and it's in the 4 times table. So we can find equivalent fractions to 7/10, 3/5, and 3/4, which have a denominator of 20, and that will make them easier for us to compare. So, starting with 7/10, we know that 10 times 2 is 20, and what we do to the denominator, we need to do to the numerator as well, and 7 times 2 is 14. Now, 3/5. 5 times 4 is 20, and 3 times 4 is 12. And finally, for 3/4, 4 times 5 is 20, and 3 times 5 is 15. So now that we know our equivalent fractions over 20, it's easy to compare these fractions. We can see that 12/20 is our smallest fraction, because that's less than 13, 14, or 15. And because that's the same as 3/5, we know that 3/5 is our smallest fraction. Then, next smallest is 13/20. Then we have 7/10, because that's equivalent to 14/20. And our largest fraction is 3/4, because that's equivalent to 15/20. So we can see the fraction bars. We have 3/5, 13/20, 7/10, and 3/4. The way that we compared these fractions was by changing 3/5, 7/10, and 3/4 into 20ths, and that made it easy for us to see which was smallest and which was largest. So here we're adding fractions, but we have a problem, because to add fractions we need the denominators to be the same, but here our denominators are different. So what we need to do is to use equivalent fractions to help us make the denominators the same. First we have 3/4 plus 1/8. Now 8 is in the 4 times table, so we can find a fraction equivalent to 3/4 which has a denominator of 8. We can use multiplication to find equivalent fractions, and 4 times 2 is 8. What we do to the denominator, we need to do to the numerator as well, and 3 times 2 is 6. So we found that 3/4 is equivalent to 6/8. So we can rewrite our question. Instead of 3/4, we can write 6/8, because that's equivalent to 3/4. And we're adding 1/8. So now our denominators are the same, so we keep the denominator the same in our answer and just add the numerator. 6 plus 1 is 7, so our answer is 7/8. Now we have 2/5 plus 2/15. Now 15 is in the 5 times table, so to add these fractions, we need to find a fraction equivalent to 2/5, which has a denominator of 15. 5 times 3 is 15, and 2 times 3 is 6. So now we can rewrite our question. Instead of 2/5, we can write 6/15, because that's the same as 2/5. That's equivalent to 2/5. We're adding 2/15, so the denominator stays the same in our answer, and 6 plus 2 is 8, so our answer is 8/15. Now we have 7/12 plus 1/4. Now 12 is in the 4 times table, so this time it's the second fraction, it's the fraction we're adding that we need to find an equivalent fraction for. We need to find an equivalent fraction to 1/4, which has a denominator of 12. 4 times 3 is 12, and what we do to the denominator, we need to do to the numerator as well. And 1 times 3 is 3. So we know that 1/4 is equivalent to 3/12. So we can rewrite our question. We still start with 7/12, but instead of adding 1/4, we can add 3/12, because that's equivalent to 1/4. So the denominators are the same, so we keep the denominator the same in our answer and just add the numerator. 7 plus 3 is 10, so our answer is 10/12. We can show what we did with fraction bars. First, we had 3/4 and we were adding 1/8. We changed 3/4 into 6/8, which meant that we could add the 1/8 to get 7/8 as our answer. Here we started with 2/5 and we were adding 2/15. We changed 2/5 into 6/15, and that meant that we could add the 2/15 to get 8/15 as our answer. Here we started with 7/12 and we were adding 1/4. We changed 1/4 into 3/12, which meant that we could add it to the 7/12 to get 10/12 as our answer. Now for these questions, we're subtracting fractions with different denominators. But to subtract fractions, we need the denominators to be the same. So we need to use what we know about equivalent fractions to help us. First, we have 3/4 minus 3/8. Now if we look at our denominators, 8 is in the 4 times table, so we can find a fraction equivalent to 3/4, which has a denominator of 8. To find equivalent fractions, we use multiplication. 4 times 2 is 8, and when we're finding equivalent fractions, what we do to the denominator, we need to do to the numerator as well, and 3 times 2 is 6. So, now that we know that 3/4 is equivalent to 6/8, we can rewrite our question. Instead of writing 3/4, we can write 6/8 minus 3/8, because we've seen that 3/4 is equivalent, so has the same value as 6/8. So now our denominators are the same, so we keep the denominator the same in our answer, and 6 minus 3 is 3, so our answer is 3/8. Now we have 4/5, and we need to subtract 3/20. Again, we've got fractions with different denominators. But 20 is in the 5 times table, so we can find a fraction equivalent to 4/5, which has a denominator of 20. 5 times 4 is 20, and what we do to the denominator, we do to the numerator as well. 4 times 4 is 16, so we know that 4/5 is equivalent or has the same value as 16/20. So, instead of 4/5 minus 3/20, we can rewrite our question as 16/20 minus 3/20. So now our denominators are the same, so we keep the denominator the same in our answer, and 16 minus 3 is 13, so our answer is 13/20. Now we have 11/12 minus 1/4. Again, we've got fractions with different denominators. But 12 is in the 4 times table, so we can find a fraction equivalent to 1/4, which has a denominator of 12. So this time, it's the number we're subtracting that we need to find an equivalent fraction for. That's because it's always easier to make the denominator larger, so we need to look at our largest fraction and find an equivalent fraction for our other fraction. Now, 4 times 3 is 12, and 1 times 3 is 3, so we can rewrite our question. This time, we're keeping the 11/12 the same, but instead of subtracting 1/4, we're subtracting 3/12, because we've seen that that's equivalent to 1/4. Now our denominators are the same, so they stay the same in the answer, and 11 minus 3 is 8, so our answer is 8/12. And we can show fraction bars to see what we were doing here. So in this first question, we started with 3/4, but we needed to subtract 3/8. So we changed those 3/4 into 6/8, and you can see that that's equivalent because we have the same amount of the fraction bar shaded in 3/4 and now in 6/8. But now we can take 1, 2, 3 of those eighths away to leave us with the 3/8 that we have in our answer. Then for this question, we started with 4/5, but because we wanted to subtract 20ths, we changed those 4/5 into 16/20, so that we could take away 3/20 to leave us with the 13/20 that we have in blue on our fraction bar, and that's our answer. Then we started with 11/12. We needed to take away 1/4, but 1/4 is the same as 3/12. You can see if we shade the fraction bar, 1/4 is yellow, and that's the same as 3/12. So what we were left with is the 8/12 that we have left in blue. So here we have some missing fraction, addition and subtraction problems. But we can use the same methods to work out our missing fractions as we use to work out missing numbers when they're whole numbers. So first, 3/5 plus something equals 9/10. Well, whenever we have a missing number or a missing fraction in an addition problem, we always use subtraction to find our missing number. So we need to work out 9/10 minus 3/5, and that will give us our missing fraction. But to subtract fractions, we need the denominators to be the same. Now 10 is in the 5 times table, so we can find an equivalent fraction to 3/5, which has a denominator of 10. So we can rewrite our question. The 9/10 stays the same, but instead of subtracting 3/5, we can subtract 6/10. That's equivalent to 3/5 because 5 times 2 is 10 and 3 times 2 is 6. So now the fractions have the same denominator, so the denominator stays the same in our answer, and 9 minus 6 is 3. So our missing fraction is 3/10. Now 3/4 minus what equals 1/8. So here it's the second number of the subtraction or the subtrahend that's missing. And when we have a missing subtrahend, when it's the second number that's missing, we still use subtraction to find our missing number. So we need to work out 3/4 minus 1/8 to find our missing number. Again, to subtract fractions, we need the denominators to be the same. Now 8 is in the 4 times table, so we can find an equivalent fraction to 3/4, which has a denominator of 8. That's 6/8, because we use multiplication to find equivalent fractions. 4 times 2 is 8, and 3 times 2 is 6. So now, when we subtract the 1/8, the denominator stays the same, and 6 minus 1 is 5. So our missing fraction here is 5/8. Now, something minus 2/9 equals 2/3. So here, it's the first number in the subtraction problem that's missing, so we have a missing minuend. And here, we need to use addition to find our missing number, because remember, subtraction problems can be read backwards as addition problems. So if we work out 2/3 plus 2/9, that will give us our missing number. Again, we need the denominators to be the same, so instead of 2/3, we can have 6/9. That's equivalent because 3 times 3 is 9, and 2 times 3 is 6. So now we can add 2/9, the denominator stays the same, and 6 plus 2 is 8. So our missing fraction is 8/9. Now let's see what we did here. So for this first question, we started with 3/5, and we knew that something had been added to make 9/10. To work out what had been added, we changed those 3/5 to 6/10, and when we subtract 6/10 from 9/10, we get 3/10. Then, for this middle question, we had 3/4, and we knew that something had been subtracted to make 1/8. 3/4 is the same as 6/8, so we can see that 5/8 must have been subtracted to leave just 1/8. Then we knew that 2/9 had been subtracted to leave 2/3. But because 2/3 is the same as 6/9, we can add that to 2/9 to get 8/9 altogether. So that was our missing minuend. Now we're adding fractions with different denominators, but this time we have 2 answer boxes. That's because adding these fractions will give us a total of more than one whole, so we can write our answer as both an improper fraction and a mixed number. So first we have 4/5 plus 3/10. Now we know that to add fractions we need the denominators to be the same, and 10 is in the 5 times table, so we can find a fraction equivalent to 4/5, which has a denominator of 10. 4/5 is the same as 8/10, because 5 times 2 is 10, 4 times 2 is 8. So now we can rewrite our question. Instead of 4/5, we can write 8/10, because that's equivalent to 4/5. And we can add the 3/10, because now we have a common denominator. So the denominator stays the same in our answer, and 8 plus 3 is 11. So, as an improper fraction, our answer is 11/10. But we can change that back into a mixed number by dividing. 11 divided by 10 is 1 remainder 1, because 1 times 10 is 10, then we need 1 more to get to 11. So, as a mixed number, our answer is 1 and 1/10. Now we have 5/12 plus 3/4. Now 12 is in the 4 times table, so this time we need to find a fraction equivalent to 3/4, which has a denominator of 12. 4 times 3 is 12, and when we find equivalent fractions, what we do to the denominator, we do to the numerator as well, and 3 times 3 is 9. So now we can rewrite our question. The 5/12 stays the same, but instead of adding 3/4, we can add 9/12, because we've seen that that's equivalent to 3/4. But now we have a common denominator. So that stays the same in our answer, and 5 plus 9 is 14. So, as an improper fraction, Our answer is 14/12. But again, we can write that as a mixed number. 14 divided by 12 is 1 remainder 2, because 1 times 12 is 12, and then we need 2 more to get to 14. But let's think about what we did here. So for this first question, we had 4/5, and we were adding 3/10. We changed those 4/5 into 8/10, and when we put them together, we saw that we had 11/10 altogether. But when we changed that back into a mixed number, we got 1 and 1/10. Then we had 5/12, and we were adding 3/4. We saw that 3/4 was the same as 9/12, so when we put those together, that gave us 14/12. But as a mixed number, that's the same as 1 whole and 2/12. Now, we need to subtract a fraction from a mixed number. But if we look at our denominators, we can see that they're not the same. And to subtract fractions, we need the denominators to be the same. So, for this first question, we need to find a fraction equivalent to 1/2, which has a denominator of 10. So instead of writing 1 and a half, we can write 1 and 5/10. That's equivalent because we use multiplication to find equivalent fractions. 2 times 5 is 10. What we do to the denominator, we do to the numerator as well, and 1 times 5 is 5. But we need to subtract 7/10, and we only have 5/10 in our mixed number. So we need to change this mixed number to an improper fraction. That's 15/10, because 1 times 10 is 10, plus 5 is 15, and the denominator stays the same. So now we can subtract 7/10. The denominator stays the same in our answer, and 15 minus 7 is 8. So our answer is 8/10. Now we have 1 and 1/3 minus 5/6. Again, we need the denominators to be the same. So we need to find a fraction equivalent to 1/3, which has a denominator of 6. So instead of 1 and 1/3, we can write 1 and 2/6. That's equivalent because 3 times 2 is 6 and 1 times 2 is 2. But we need to subtract 5/6, and we only have 2/6 in our mixed number, so we need to change it to an improper fraction. 1 times 6 is 6, plus 2 is 8, so that's 8/6. So now we can subtract 5/6. The denominator stays the same. 8 minus 5 is 3, so our answer is 3/6. Now we have 1 and 1/8, but we need to subtract 1/4. Again, we need the denominators to be the same, but this time we need to find a fraction equivalent to 1/4, which has a denominator of 8. Remember, when we find equivalent fractions, we're looking to make the smaller denominators larger. So here, the 1 and 1/8 stays the same, but instead of subtracting 1/4, we can subtract 2/8, because 4 times 2 is 8, 1 times 2 is 2, so these fractions are equivalent. But again, we only have 1/8 in our mixed number, and we need to subtract 2/8, so we can change our mixed number to an improper fraction. 1 times 8 is 8, plus 1 is 9, so we can rewrite our question as 9/8 minus 2/8. The denominator stays the same. 9 minus 2 is 7, so our answer is 7/8. So let's think about what we did here. For this first question, we started with 1 and a half. We changed that to 1 and 5/10, but we needed to subtract 7/10, so we changed our 1 whole into tenths as well, and that gave us 15/10. Then we could subtract 1, 2, 3, 4, 5, 6, 7 of those tenths to leave us 8/10 as our answer. Then we started with 1 and 1/3, but we were taking away sixths. So first we saw that 1 and 1/3 is the same as 1 and 2/6, But because we needed to take 5/6 away, we needed to turn our 1 whole into sixths as well. So that's 8/6. Then we could subtract 1, 2, 3, 4, 5 of those sixths to leave us 3/6 as our answer. Finally, we had 1 and 1/8, but we needed to subtract 1/4. We changed 1 and 1/8 into 9/8, and we saw that 1/4 is the same as 2/8. So if we subtract 2 of those eighths, we get 7/8 as our answer. So here we've got some missing fraction problems, but we solve these in the same way that we solve missing number problems with whole numbers. So first, 1 and 1/6 minus something equals 2/3. So here, it's the subtrahend, or the second number, of the subtraction question that's missing, so we still use subtraction to find our missing number. We can work out 1 and 1/6 minus 2/3, and that will give us our missing fraction. But to subtract fractions, we need the denominators to be the same, so we need to find a fraction equivalent to 2/3, which has a denominator of 6. So we can rewrite our question as 1 and 1/6 minus 4/6. That's equivalent to 2/3 because 3 times 2 is 6 and 2 times 2 is 4. But now we need to subtract 4/6, and we only have 1/6 in our mixed number. So we need to change our mixed number to an improper fraction. 1 times 6 is 6 plus 1 is 7. So that's 7/6, and now we can take 4/6 away. The denominator stays the same, and 7 minus 4 is 3. So our missing fraction here is 3/6. Now, something minus 3/4 is 5/8. So here it's the minuend, or the first number, of the subtraction that's missing. Remember, subtraction problems can be read backwards as addition problems, so to find our missing number, we can add 5/8 and 3/4. To add fractions, the denominators need to be the same, so we need to find a fraction equivalent to 3/4 with a denominator of 8. So that's the same as 6/8, because 4 times 2 is 8 and 3 times 2 is 6. So now our denominators are the same, so the denominator stays the same in our answer, and 5 plus 6 is 11. Now we could write our missing number as an improper fraction, so as 11/8, but we can turn that back into a mixed number. 11 divided by 8 is 1 remainder 3, so that's 1 and 3/8 as a mixed number, because 1 times 8 is 8, then we need 3 more to get to 11. Now, something plus 5/6 equals 1.5. So here we have a missing number addition, and whenever we have a missing number addition, we always use subtraction to find our missing number. So we need to work out 1.5 minus 5/6. We need the denominators to be the same, so 1.5 is the same as 1 and 3/6, because we use multiplication to find equivalent fractions. 2 times 3 is 6, 1 times 3 is 3. But we need to take 5/6 away, so let's turn 1 and 3/6 into an improper fraction. 1 times 6 is 6, plus 3 is 9, so that's 9/6. Now the denominator stays the same, and 9 minus 5 is 4, so our missing number is 4/6. So let's look at what we did here. For this first question, we knew that we started with 1 and 1/6, and something had been subtracted to leave 2/3. But because 2/3 is the same as 4/6, we know that the 3/6 that we have in blue must have been subtracted. Then we knew that 3/4 had been subtracted from something to leave 5/8. Now 3/4 is the same as 6/8, So if we put that together with the 5/8, we know that 11/8 or 1 whole and 3/8 must have been what we started with. Then we knew that 5/6 had been added to something to make 1½ Now 1½ is the same as 1 3/6, so the 4/6 that are in blue must have been what we started with. Now we're adding a fraction to a mixed number. So first we have 1 3/5, and we need to add 3/10. But to add fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 3/5, which has a denominator of 10. So instead of 1 3/5, we can write 1 6/10. That's equivalent to 3/5 because we use multiplication to find equivalent fractions, and 5 times 2 is 10. What we do to the denominator, we do to the numerator as well, and 3 times 2 is 6. So now we're adding 3/10. First we see if we can add the fractions. So 6/10 plus 3/10 is 9/10, and we add the fractions first, because if the fractions total more than 1 whole, we'll need to change that back into a mixed number. But for these questions we don't need to. 9/10 is less than 1, so we can just look at our whole numbers. We have 1 whole, we're not adding any whole numbers, so we still have 1 whole in our answer. That's 1 9/10. Now we have 2 2/3, and we're adding 1/9. But to add fractions, the denominators need to be the same. So instead of 2 2/3 plus 1/9, we can write 2 6/9 plus 1/9. 6/9 is equivalent to 2/3 because 3 times 3 is 9 and 2 times 3 is 6. Now we add our fractions. 6/9 plus 1/9 is 7/9, and then we have 2 wholes, and we're not adding any, so that's 2 wholes in our answer, 2 7/9. Finally, we have 1 3/8, and we're adding 1/2. This time, it's the 1/2 that we'll need to change, because 8 is in the 2 times table, so we can find a fraction equivalent to 1/2, which has a denominator of 8. So we can rewrite our question as 1 3/8 plus 4/8. That's equivalent to 1/2 because 2 times 4 is 8 and 1 times 4 is 4. So now we see if we can add our fractions. 3/8 plus 4/8 is 7/8 because remember, when we add fractions the denominator stays the same, and we have 1 whole in the question, so we need that in our answer as well. So let's think about what we did here. We started with 1 3/5, so that's 1 whole and 3/5, and we were adding 3/10. But to do that, we needed to change these 3/5 into 6/10. So when we put that together with our fraction, we got 1 9/10 as our answer. Then we had 2 2/3, and we were adding 1/9. But 2/3 is the same as 6/9, so when we added our 1/9, that gave us 7/9 as our fraction, and with the 2 wholes meant that we had 2 7/9. Finally, we had 1 3/8, and we needed to add 1/2. But 1/2 is the same as 4/8, and when we put that together, we get 1 7/8 as our answer. Now we're adding a fraction to a mixed number, but this time when we add our fractions, we'll get a total of more than 1 whole. So first we have 1 4/5, and we're adding 7/10. Now to add fractions, we need the denominators to be the same. 10 is in the 5 times table, so instead of 1 4/5, we can write 1 8/10, because to find equivalent fractions we use multiplication. 5 times 2 is 10, 4 times 2 is 8. So we're adding 7/10, but when we add our fractions, the denominator will stay the same, and 8 plus 7 is 15, so we'll get 15/10. That's more than 1 whole. We can't write 1 and 15/10 as our answer, because we can't have an improper fraction in a mixed number. So we still have 1 whole, but we need to add the 15/10 that we've got from adding our fractions. Now 15/10 is the same as 1 and 5/10, because 15 divided by 10 is 1 remainder 5, and because 1 times 10 is 10, then we need 5 more to get to 15. So we have 1 as the whole number in our question, and we've got 1 and 5/10 from adding the fractions. So adding the wholes together gives us 2, the 5/10 stays the same, so that's 2 and 5/10 as our answer. Now we have 2 and 7/8, and we need to add 1/2. But to add fractions we need the denominators to be the same. Now 8 is in the 2 times table, so we need to find a fraction equivalent to 1/2, which has a denominator of 8. So we can rewrite our question as 2 and 7/8 plus 4/8. That's the same as 1/2, because 2 times 4 is 8 and 1 times 4 is 4. But now when we add our fractions, we'll get a total of more than 1. Remember, the denominator stays the same, and 7 plus 4 is 11. So we still have our 2 wholes, but we need to add 11/8 to that. We can't write 2 and 11/8 as our answer, because we can't have an improper fraction in a mixed number. So we need to change 11/8 into a mixed number. That's 1 and 3/8, because 11 divided by 8 is 1 remainder 3, or 1 times 8 is 8, then we need 3 more to get to 11. So now 2 plus 1 is 3, the 3/8 stays the same, so our answer is 3 and 3/8. So let's think about what we did here. We started with 1 and 4/5, and we needed to add 7/10. We changed those 4/5 into 8/10, but then when we put our fractions together, that gave us 15/10. We knew that we couldn't write 1 and 15/10 as our answer, because we can't have an improper fraction in a mixed number. So we changed the 15/10 to 1 and 5/10, and putting that together with the 1 whole that we started with gave us 2 and 5/10. Then we had 2 and 7/8, and we needed to add 1/2. 1/2 is the same as 4/8, but when we put that together with the 7/8, we get 11/8, and we can't write 2 and 11/8 as our answer. We changed the 11/8 back into a mixed number, so that's 1 whole and 3/8, and putting that together with the 2 wholes that we started with gave us 3 and 3/8 as our answer. Now we're adding a fraction to a mixed number, but this time we're going to get our answer by first changing the mixed number into an improper fraction. So 1 times 5 is 5, plus 4 is 9. So 9/5 is the same as 1 and 4/5, and we're adding 7/10. But to add fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 9/5, which has a denominator of 10. That's 18/10, because to find equivalent fractions, we use multiplication. 5 times 2 is 10, and what we do to the denominator, we do to the numerator as well, and 9 times 2 is 18. We're adding 7/10 to that, and we have a common denominator. So the denominator stays the same in our answer, and 18 plus 7 is 25. So, as an improper fraction, our answer is 25 tenths. But we can turn that back into a mixed number by dividing. 25 divided by 10 is 2 remainder 5, and the denominator stays the same. So our answer is 2 and 5 tenths. Now we have 2 and 7/8 plus 1/2. We can change 2 and 7/8 into an improper fraction. Remember, we multiply the whole number by the denominator and then add the numerator. 2 times 8 is 16, plus 7 is 23. So that's 23/8 as an improper fraction. We're adding 1/2, but to add fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 1/2, which has a denominator of 8. So we can rewrite our question as 23/8 plus 4/8. That's equivalent to 1/2 because 2 times 4 is 8 and 1 times 4 is 4. Now we have a common denominator, so that stays the same in our answer, and 23 plus 4 is 27. So as an improper fraction, our answer is 27/8. If we want to turn that back into a mixed number, then we can divide 27 by 8. That's 3 remainder 3, and the denominator stays the same, so our answer is 3 and 3/8. So let's think about what we did here. For this first question, we started with 1 and 4/5, and we were adding 7 tenths. We changed 1 and 4/5 into an improper fraction, so into 9/5, but because we were adding tenths, we needed to change those 9/5 into 18 tenths. When we put that together with the 7 tenths, we got 25 tenths, and then we turned that back into a mixed number, because 25 divided by 10 is 2 remainder 5, so that's 2 and 5 tenths. Then we had 2 and 7/8, and we were adding 1/2. 2 and 7/8 is the same as 23/8, and 1/2 is the same as 4/8. So when we put that together, we get 27/8, but we turned that back into a mixed number by dividing 27 by 8. That's 3 remainder 3, so our answer is 3 and 3/8. Now we need to add mixed numbers. So first we have 2 and 1/6, and we need to add 2 and 2/3. But to add fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 2/3, which has a denominator of 6. So we can rewrite our question as 2 and 1/6 plus 2 and 4/6. 4/6 is equivalent to 2/3 because 3 times 2 is 6 and 2 times 2 is 4. So now we start by adding the fractions. So we have 1/6 plus 4/6. That's 5/6 because remember, when we add fractions, the denominator stays the same and 1 plus 4 is 5. And we can write that in our answer box because the fractions have been added and that totals less than 1 whole. If this was an improper fraction, so if the numerator was larger than the denominator, we'd need to do something else. But because 5/6 is a proper, not an improper fraction, we can write it in our answer box. But now we need to add our whole numbers. 2 plus 2 is 4, so our answer is 4 and 5/6. Now we have 2 and a half plus 1 and 1/8. So we need to make the denominators the same. 8 is in the 2 times table, so we can find a fraction equivalent to 1/2, which has a denominator of 8. So instead of 2 and a half, we can write 2 and 4/8. That's equivalent because 2 times 4 is 8. What we do to the denominator, we do to the numerator, and 1 times 4 is 4. So we're adding 1 and 1/8, and we start by adding the fractions. 4/8 plus 1/8 is 5/8, and we can write that in our answer line because it's less than 1 whole. Then we add our whole numbers. 2 plus 1 is 3, so our answer is 3 and 5/8. So let's see what we did here. For this first question, we started with 2 and 1/6, so we can show 2 whole fraction bars and 1/6 of another one, and we were adding 2 and 2/3. But to add the fractions, we changed those 2/3 into 4/6. So when we added that to the 1/6, that gave us 5/6. Then we added the whole numbers, and 2 plus 2 is 4, so that gave us our answer, 4 and 5/6. Then for this question, we started with 2 and a half, and we were adding 1 and 1/8. We changed the 1/2 into 4/8, which meant we could add the 1/8 to get 5/8 as our fraction. Then adding the 1 whole gave us 3 wholes, so that's 3 and 5/8. Now we're adding mixed numbers, but this time when we add our fractions, we'll get a total of more than 1 whole, so we'll get an improper fraction, which means that we'll need to use a slightly different method. So first we have 2 and 3/4, and we're adding 2 and 7/12. But we know that when we add fractions, we need the denominators to be the same. So instead of 2 and 3/4, we can write 2 and 9/12. To find equivalent fractions, we use multiplication. 4 times 3 is 12, and 3 times 3 is 9. We're adding 2 and 7/12, so now the fractions have a common denominator. We start by adding the fractions, and we know that when we add fractions, the denominator stays the same, and 9 plus 7 is 16. But we can't write 16/12 in our answer box because we can't have an improper fraction in a mixed number, so we need to use a slightly different method. Here we can see 2 plus 2 is 4, but we need to add 16/12 that we've got from adding 9/12 and 7/12. What we do is change 16/12 back into a mixed number. So we can rewrite our question again as 4 plus 1 and 4/12. That's the same as 16/12 because 16 divided by 12 is 1 remainder 4, or because 1 times 12 is 12, and then we need 4 more to get to 16. So now 4 plus 1 is 5, the 4/12 stays the same, so our answer is 5 and 4/12. So notice, even though the whole numbers in the question are 2 and 2, the answer for the whole numbers is 5 because we got an extra whole number by adding our fractions. Now we have 2 and 9/10 plus 1 and a half. So to add fractions, we need the denominators to be the same, so we can rewrite our question as 2 and 9/10 plus 1 and 5/10. That's the same as 1/2 because 2 times 5 is 10 and 1 times 5 is 5. So when we're adding mixed numbers, we start by seeing if we can add our fractions. The denominator stays the same, and 9 plus 5 is 14. But again, we can't write 14/10 in our answer box because we can't have an improper fraction in a mixed number. So instead, 2 plus 1 is 3, and we can add 14/10 that we've got from adding 9/10 and 5/10. But we can change those 14/10 back into a mixed number. So we can rewrite our question again as 3 plus 1 and 4/10 because 14 divided by 10 is 1 remainder 4. So now 3 plus 1 is 4, the 4/10 stays the same, so that gives us 4 and 4/10 as our answer. So let's see what we did here. We started with 2 and 3/4, so 2 wholes and 3/4, and we were adding 2 and 7/12. But we needed to get the denominators the same, so we changed those 3/4 into 9/12. Then, when we added the 7/12, we got 16/12, but we couldn't write 4 and 16/12 as our answer because we can't have an improper fraction in a mixed number. So instead, we changed those 16/12 into 1 whole and 4/12. That meant that we had 5 wholes altogether and 4/12. Then for this question, we had 2 and 9/10, and we were adding 1 and a half. We changed the half into 5/10, but then when we added the fractions together, we got 14/10, and we knew that we couldn't write 3 and 14/10 as our answer because we can't have an improper fraction in a mixed number. So instead, we turned those 14/10 into 1 whole and 4/10, and when we added that to the 3 wholes, we got our answer 4 and 4/10. Now we're adding mixed numbers, but this time we're going to get our answer by first changing both of our mixed numbers to improper fractions. Remember, to change a mixed number to an improper fraction, we multiply the whole number by the denominator and then add the numerator. So, to change 2 and 3/4 to an improper fraction, we do 2 times 4, which is 8, then we add 3, which gives us 11. So that's our numerator, and the denominator stays the same. We're adding 2 and 7/12, but we can turn that to an improper fraction as well. 2 times 12 is 24, plus 7 is 31, so that's our numerator, and the denominator stays the same. So now we have improper fractions, but to add fractions, we need the denominators to be the same. So we need to find an equivalent fraction to 11/4, which has a denominator of 12. That's 33/12, because remember, to find equivalent fractions, we use multiplication. 4 times 3 is 12, and what we do to the denominator, we do to the numerator as well, and 11 times 3 is 33. So now we can add the 31/12, and remember, when we're adding fractions with a common denominator, the denominator stays the same in our answer, and 33 plus 31 is 64. So, as an improper fraction, our answer is 64/12. But we can turn that back into a mixed number by dividing. 64 divided by 12 is 5 remainder 4, and the denominator stays the same, so our answer is 5 and 4/12. We can check that because 5 times 12 is 60, plus 4 is 64. Now we have 2 and 9/10, plus 1 and a half. So first, 2 and 9/10 as an improper fraction is 29/10. That's because 2 times 10 is 20, plus 9 is 29, and the denominator stays the same. Now, 1 and a half is 3 over 2, or 3 halves, as an improper fraction, because 1 times 2 is 2, plus 1 is 3. But, again, to add fractions, we need the denominators to be the same. Now 10 is in the 2 times table, so we can find an equivalent fraction to 3 halves, which has a denominator of 10. So we keep the 29/10 the same, but instead of adding 3 halves, we can add 15/10. That's because 2 times 5 is 10, and what we do to the denominator, we do to the numerator as well, and 3 times 5 is 15. So now we have a common denominator, so that stays the same in our answer, and 29 plus 15 is 44. So, as an improper fraction, our answer is 44 tenths. But we can turn that back into a mixed number by dividing. 44 divided by 10 is 4 remainder 4, and the denominator stays the same. So let's have a look at what we did here. For this first question, we had 2 and 3 quarters, and we were adding 2 and 7 twelfths. We changed 2 and 3 quarters into 11 quarters, and we changed 2 and 7 twelfths into 31 twelfths. But to add fractions, we need the denominators to be the same, so we changed those 11 quarters into 33 twelfths, which meant that we had 64 twelfths altogether. But to turn that back into a mixed number, we divided 64 by 12, and that's 5 remainder 4. So, as a mixed number, our answer is 5 and 4 twelfths. Then we had 2 and 9 tenths, and we were adding 1 and a half. We changed 2 and 9 tenths into 29 tenths, and we changed 1 and a half into 3 halves. But to add fractions, we needed the denominators to be the same. So we changed those 3 halves into 15 tenths, which meant when we put them together, we had 44 tenths. But to change that back into a mixed number, we divided 44 by 10, and that gave us 4 remainder 4, so 4 and 4 tenths. Now we need to subtract a fraction from a mixed number. So first we have 1 and 4 fifths minus 7 tenths. But we know that to subtract fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 4 fifths with a denominator of 10. So we can rewrite our question as 1 and 8 tenths minus 7 tenths. 8 tenths is equivalent to 4 fifths because to find equivalent fractions we use multiplication, and 5 times 2 is 10. What we do to the denominator we do to the numerator as well, and 4 times 2 is 8. So now we subtract the fraction first. 8 tenths minus 7 tenths is 1 tenth, and we have 1 whole, and we're not taking any whole numbers away, so we still have 1 whole in our answer, which is 1 and 1 tenth. Now we have 2 and 1/3 minus 1/12. We need to find a fraction equivalent to 1/3, which has a denominator of 12, so that our denominators are the same. So we rewrite our question as 2 and 4 twelfths minus 1/12. 4 twelfths is equivalent to 1/3 because 3 times 4 is 12 and 1 times 4 is 4. So now we subtract 1/12 from 4 twelfths, that's 3 twelfths, and we have 2 wholes, and we're not taking any away, so there's 2 wholes in our answer. Finally, we have 1 and 5/6 minus 1/2. This time, it's the fraction we're subtracting that we need to change. 6 is in the 2 times table, so instead of subtracting 1/2, we can subtract 3/6. That's equivalent because 2 times 3 is 6 and 1 times 3 is 3. So now 5/6 minus 3/6 is 2/6, and we still have 1 whole because we're not subtracting anything. So our answer is 1 and 2/6. So let's see what we did here. For this first question, we started with 1 and 4 fifths, but we needed to subtract 7 tenths. So we changed those 4 fifths into 8 tenths, and then we could subtract 7/10 to leave 1 whole and 1/10. Then we had 2 and 1/3, but we needed to subtract 1/12. So we changed that third into 4/12, and when we subtracted 1, that left us with 2 wholes and 3/12 as our answer. Then we had 1 and 5/6, but we needed to subtract 1/2. Now 1/2 is the same as 3/6, but if we show 1/2 on this fraction bar and take 1/2 away, you can see that subtracting 1/2 is the same as subtracting 3/6. So that leaves us with 1 whole and 2/6 left in blue. So here we're subtracting a fraction from a mixed number, but this time the fraction we're subtracting is larger than the fraction in our mixed number. So we'll need to exchange with our whole number to do the subtraction. So first we have 2 and 1/5 minus 7/15. We know that to subtract fractions we need the denominators to be the same. So we need to find an equivalent fraction to 1/5 which has a denominator of 15. So we can write 2 and 1/5 as 2 and 3/15. That's equivalent because 5 times 3 is 15 and 1 times 3 is 3. But we need to subtract 7/15 and we only have 3/15 in our mixed number. So what we can do here is either turn the mixed number into an improper fraction or do what I like to do and just exchange with the whole number. So 1 less than 2 is 1, and that means that we can have 15 more 15ths. So we can add the denominator to the numerator. 15 plus 3 is 18, and the denominator stays the same. So 1 and 18/15 is the same as 2 and 3/15. That's because 1 whole is 15/15. But now we can subtract our 7/15. So 18/15 minus 7/15 is 11/15, and then we now have only 1 whole, and we're not taking any wholes away, so we have 1 whole in our answer. Now 2 and 3/8 minus 1/2. Again, we know that to subtract fractions, we need the denominators to be the same. Now 8 is in the 2 times table, so we can find a fraction equivalent to 1/2 with a denominator of 8. So this time the 2 and 3/8 stays the same, but instead of subtracting 1/2, we can subtract 4/8. That's equivalent because 2 times 4 is 8 and 1 times 4 is 4. But now we need to subtract 4/8, and we only have 3/8 in our mixed number. So again, we can exchange 1 whole for 8 more 8ths. So 1 less than 2 is 1, but that gives us 8 more 8ths in our fraction. So 8 plus 3 is 11. So that's 1 and 11/8. So now we can take 4/8 away. 11/8 minus 4/8 is 7/8, and 1 minus nothing is 1, so our answer is 1 and 7/8. Let's have a look at the fraction bars to see what we did here. So for this first question, we started with 2 and 1/5, but we needed to take 7/15 away. We changed the 1/5 into 3/15, but we still couldn't take 7 away. So we changed one of our wholes for 15 more 15ths. That meant that we had 1 and 18/15 altogether. So we could subtract 1, 2, 3, 4, 5, 6, 7 of those to leave 1 whole and 11/15. Then in this question we started with 2 and 3/8. We worked out that 1/2 was the same as 4/8, but we only had 3/8, so we exchanged one of our wholes for 8 more 8ths. That gave us 1 and 11/8. So we could take 1, 2, 3, 4/8 away, because that's the same as taking a half away, and that left us with 1 and 7/8. So here we're subtracting a fraction from a mixed number, and this time we're going to subtract by first turning our mixed number into an improper fraction. So to turn a mixed number to an improper fraction, we multiply the whole number by the denominator and then add the numerator. So 2 times 5 is 10, plus 1 is 11, so that's 11/5. But we need to subtract 7/15, and to subtract fractions, we need the denominators to be the same. Now 15 is in the 5 times table, so we can find a fraction equivalent to 11/5, which has a denominator of 15. That's 33/15, because we use multiplication to find equivalent fractions. 5 times 3 is 15, and 11 times 3 is 33. So now we can take 7/15 away, because we have a common denominator. So the denominator stays the same in our answer, and 33 minus 7 is 26. So as an improper fraction, our answer is 26/15. But we can turn that back into a mixed number by dividing. 26 divided by 15 is 1 remainder 11, and the denominator stays the same. And we can check that that works, because 1 times 15 is 15, then if we add 11, we get 26. Now we have 2 and 3/8 minus 1/2. Again, we can turn this mixed number into an improper fraction. 2 times 8 is 16, plus 3 is 19, so that's 19/8 as an improper fraction, and we're subtracting 1/2. But again, to subtract fractions, we need the denominators to be the same. Now 8 is in the 2 times table, so this time we need to find an equivalent fraction for the fraction that we're subtracting. We need to find a fraction equivalent to 1/2, which has a denominator of 8. So we can rewrite our question as 19/8 minus 4/8. That's equivalent because 2 times 4 is 8, and 1 times 4 is 4. So now the denominator stays the same in our answer. 19 minus 4 is 15, so if we can write our answer as an improper fraction, we have 15/8. But if we want to turn that back into a mixed number, 15 divided by 8 is 1 remainder 7, the denominator stays the same, so our answer is 1 and 7/8. So let's use fraction bars to see what we did here. For this first question, we started with 2 and 1/5. We needed to take 7/15 away. First of all, we changed 2 and 1/5 into an improper fraction, so into 11/5. But because we were taking 15ths away, we changed those 11/5 into 33/15, so that we could subtract 7/15. And if we take away 1, 2, 3, 4, 5, 6, 7, that leaves us with 26/15. But 26/15 is the same as 1 and 11/15, so that's our answer as a mixed number. Then we had 2 and 3/8, and we needed to subtract 1/2. We changed 2 and 3/8 into 19/8, so into an improper fraction, and we worked out that 1/2 is the same as 4/8. So if we take away 1, 2, 3, 4 of those eighths, that leaves us with 15/8, which is the same as 1 whole and 7/8. Now here we're subtracting mixed numbers. So first we have 3 and 5/6 minus 1 and 2/3. But we know that to subtract fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 2/3, which has a denominator of 6. So we can rewrite our question as 3 and 5/6 minus 1 and 4/6. That's equivalent to 2/3 because 3 times 2 is 6 and 2 times 2 is 4. Now that we have our common denominator, we see if we can subtract the fraction. So we have 5/6 minus 4/6. That gives us 1/6 in our answer. And then we look at our whole numbers. We have 3 minus 1, which is 2, so our answer is 2 and 1/6. Now we have 2 and a half minus 1 and 1/8. Again, we need the denominators to be the same, so instead of 2 and 1/2, we can write 2 and 4/8. That's equivalent to 1/2 because 2 times 4 is 8 and 1 times 4 is 4. Now we're subtracting 1 and 1/8. So first we see if we can subtract the fraction, and here we can do 4/8 minus 1/8 because the fraction we're subtracting is smaller. If it isn't, then we'll need to use a different method, but we'll come on to that on the next video. 4/8 minus 1/8 is 3/8, and 2 minus 1 is 1, so our answer is 1 and 3/8. So let's look at what we did here. We started with 3 and 5/6. We needed to subtract 1 and 2/3, but we found that 2/3 is the same as 4/6. So if I colour in 4 of those 6ths in yellow, you can see that's the same as 2/3. We were also taking away 1 whole, and that left us with our answer of 2 wholes and 1/6 left in blue here. Then we had 2 and 1/2. We saw that 2 and a half is the same as 2 and 4/8. So we were subtracting 1/8, then we subtracted 1 whole, and that left us with 1 and 3/8 as our answer. So here we're subtracting mixed numbers, but this time the fraction in the number that we're subtracting is larger than the fraction in the number that we're subtracting from. So first we have 2 and 1/4 minus 1 and 11/12. We know that to subtract fractions we need the denominators to be the same, so we need to find an equivalent fraction for 1/4 which has a denominator of 12. So instead of 2 and 1/4, we can rewrite our question with 2 and 3/12. That's equivalent to 1/4 because 4 times 3 is 12 and 1 times 3 is 3. But we need to subtract 1 and 11/12, so the fraction in our subtrahend is larger than the fraction in our minuend. So what we can do here is exchange 1 whole for 12 more 12ths. So 1 less than 2 is 1, and that gives us 12 more 12ths, so we can add the denominator to the numerator. 12 plus 3 is 15, the denominator stays the same, so 1 and 15/12 is the same as 2 and 3/12. But now we can subtract 1 and 11/12. 15/12 minus 11/12 is 4/12, and 1 minus 1 is nothing, so our answer is just 4/12. Now we have 3 and 3/10 minus 1 and a half. Again, we need to make the denominators the same, so we need to find a fraction equivalent to 1/2 which has a denominator of 10. So we can rewrite our question as 3 and 3/10 minus 1 and 5/10. That's equivalent to a half because 2 times 5 is 10 and 1 times 5 is 5. But here 5/10 is larger than 3/10, so again we need to exchange with our whole number. We need to exchange one of our wholes for 10 more tenths. So 1 less than 3 is 2, and that gives us 10 more tenths, so 10 plus 3 is 13, and the denominator stays the same. So 2 and 13/10 is the same as 3 and 3/10, but now we can subtract 1 and 5/10. 13/10 minus 5/10 is 8/10, and 2 minus 1 is 1, so our answer is 1 and 8/10. Now let's show fraction bars to see what we did. So for this first question, we started with 2 and 1/4, but we needed to subtract twelfths, so we changed that 1/4 into 3/12. But we needed to subtract 11/12, so we exchange one of our wholes for 12 more twelfths, and if we do that here, we now have 1 whole and 15/12. So now we can take 11/12 away, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and we were also subtracting 1 whole, and that left us with just 4/12 left in blue. Then for this question, we started with 3 and 3/10. We were subtracting 1 and a half, but 1 and a half is the same as 1 and 5/10, and we only had 3/10. So we exchanged one of our wholes for 10 more tenths. That meant that we had 2 wholes and 13/10. So we could take 5/10 away to give us 8/10, and we also needed to subtract 1 whole, and that gave us 1 and 8/10 as our answer. Now we're subtracting mixed numbers, but this time we're going to get our answer by first changing both of our mixed numbers to improper fractions. Remember, to change a mixed number to an improper fraction, we multiply the whole number by the denominator and then add the numerator. So here, 2 times 4 is 8, plus 1 is 9. So 9/4 is the same as 2 and 1/4. We're subtracting 1 and 11/12, but we can turn that into an improper fraction as well. 1 times 12 is 12, plus 11 is 23. So we can subtract 23/12. But to subtract fractions, we need the denominators to be the same. So we need to find a fraction equivalent to 9/4, which has a denominator of 12. 9/4 is the same as 27/12. That's because we use multiplication to find equivalent fractions. 4 times 3 is 12, and 9 times 3 is 27. And we know that we're subtracting 23/12, so now we have a common denominator, so the denominator stays the same in our answer, and 27 minus 23 is 4, so our answer is 4/12. Now we have 3 and 3/10 minus 1 and a half. We can change both of these mixed numbers into improper fractions. 3 times 10 is 30, plus 3 is 33, so that's 33/10 because the denominator stays the same. We're subtracting 1 and a half, but we can turn that into an improper fraction as well. 1 times 2 is 2, plus 1 is 3, and the denominator stays the same, so 1 and a half is the same as 3/2. But to subtract fractions, we need the denominators to be the same. Now 10 is in the 2 times table, so we can find a fraction equivalent to 3/2, which has a denominator of 10. So let's rewrite our question. The 33/10 stays the same, but instead of 3/2, we can subtract 15/10. That's equivalent to 3/2 because 2 times 5 is 10, and what we do to the denominator, we do to the numerator, and 3 times 5 is 15. So now we have a common denominator, so the denominator stays the same in our answer, and 33 minus 15 is 18. So as an improper fraction, our answer is 18/10. But we can turn that back into a mixed number by dividing. 18 divided by 10 is 1 remainder 8, and the denominator stays the same as it was down here. So our answer is 1 and 8/10. And we can check that because 1 times 10 is 10, and then we need 8 more to get to 18. So let's show fraction bars to see what we did here. For this first question, we started with 2 and 1/4. We changed that into an improper fraction, so we got 9/4. But we were subtracting twelfths, so we changed those 9/4 into 27/12. Then we could subtract 23 of those twelfths to leave us with just the 4/12 left in blue here as our answer. Then for this question, we started with 3 and 3/10. We changed that to 33/10, so changed it to an improper fraction. We were subtracting 1.5, but we saw that that's the same as 3/2, and 3/2 is equivalent to 15/10. So if we take away 15 of these tenths, that leaves us with 18/10 left in blue. But 18/10 as a mixed number is 1 and 8/10, because 18 divided by 10 is 1 remainder 8. So as a mixed number, our answer is 1 and 8/10. Let's learn how to write a remainder as a fraction. So first we have 10 divided by 3. That's 3 remainder 1, because 3 times 3 is 9, and then we need one more to get to 10. But we can write that as a fraction. So that's 3 because we have 3 wholes. Then the remainder 1 is written as the numerator, and the denominator is 3 because that's the number that we're dividing by. That's the divisor. So our answer is 3 and 1/3. Notice it's not 3 remainder 1/3. It's 3 remainder 1, but if we're writing the remainder as a fraction, we just write 3 and 1/3. We just write the whole number and the fraction without writing remainder. So what is 10 divided by 4? Well, that's 2 remainder 2, because 2 times 4 is 8, and then from 8 we need 2 more to get to 10. But again, we can write the remainder as a fraction. We have 2 because we have 2 wholes, then we have 2 as the numerator because we always write the remainder as the numerator, and then the denominator is the divisor, so that's 4 because we're dividing by 4. So our answer is 2 and 2/4. Now we have 709 divided by 5. So here we're going to need to use short division. 7 divided by 5 is 1 remainder 2, because 1 times 5 is 5, then we need 2 more to get to 7. 20 divided by 5 is exactly 4 with no remainder. But 9 divided by 5 is 1 remainder 4, because 1 times 5 is 5, but then we need 4 more to get to 9. So we can write 141 as our whole number, 4, so the remainder 4 as our numerator, and then the denominator is 5 because that's our divisor. That's the number we're dividing by. Now 709 divided by 6, so we can write it out as a short division. 7 divided by 6 is 1 remainder 1, because 1 times 6 is 6, then we need 1 more to get to 7. 10 divided by 6 is 1 remainder 4, because 1 times 6 is 6, then we need 4 more to get to 10. And 49 divided by 6 is 8 remainder 1, because 8 times 6 is 48, then we need 1 more to get to 49. But again, we can write our remainder as a fraction. 118 is our whole number, then 1 is our numerator because that's the remainder, and then 6 is our denominator because that's the number that we were dividing by. So our answer is 118 and 1/6. Now let's think back to this first question. We had 10 divided by 3, so we can think of this as sharing 10 blocks between 3 circles. We know that we can share out 9 of those blocks, but then we have 1 remainder. So 10 divided by 3 is 3 because we have 3 blocks in each of our circles, remainder 1 because there's 1 block that we haven't been able to share out. And you might have been taught that we can't share it out because we can't have unequal groups when we're dividing. But what we can do is turn this 1 whole block into thirds, and we can see that 1 whole is the same as 3 thirds. But now that we've changed 1 whole into thirds, we can share out those thirds. So we have 3 wholes and 1/3 of a block in each group. So that's why our answer is 3 and 1/3. And let's look at the second question, 10 divided by 4. Well, we can share out 8 blocks between 4 groups to get 2 blocks in each group. So 10 divided by 4 is 2 remainder 2, because there are 2 blocks in each group, but then there are 2 blocks that we haven't been able to share out. But this time, what we can do is split each of our blocks into quarters. And the reason we're splitting them into quarters, not into thirds like we did in the last question, is because we're dividing by 4. So we split each block into 4 quarters, which can be shared out, and then we can split this block into quarters as well and share those out. So now we have 2 wholes and 2 quarters in each of our groups, and that's why our answer is 2 and 2 quarters. Now you might notice that 2 quarters is the same as 1/2, so we could push these blocks together to make 2 and 1/2. Now for these questions, we're finding a unit fraction of a number. Remember, a unit fraction is any fraction that has a numerator of 1. And normally, to find a unit fraction of a number, we can just divide by the denominator. But here, 13 isn't in the 5 times table, 17 isn't in the 4 times table, and 22 isn't in the 5 times table. So, for these questions, we're going to get a mixed number as our answer. So, what we can do is write out the question as 1 times 13 over 5. So, the numerator times the whole number over the denominator. 1 times 13 is 13, and the denominator is 5. So, we have 13/5 as an improper fraction, and we can turn that back into a mixed number by dividing, because remember, a fraction is really a division. So we're doing the same thing, dividing by the denominator, but we've just represented that division as a fraction. So 13 divided by 5 is 2 remainder 3, and the denominator stays the same. So 1/5 of 13 is 2 and 3/5. Now we have 1/4 of 17. So we can write that out as 1 times 17 over 4. And this is useful because it will be clear in our next lesson, when we're finding a fraction of a number that isn't a unit fraction, what we need to do. But 1 times 17 is 17, so we can represent 17 divided by 4 as a fraction 17 over 4. To turn that back into a mixed number, we divide, and 17 divided by 4 is 4 remainder 1, and the denominator stays the same. And we can check 4 times 4 is 16, plus 1 is 17. Finally, we have 1/5 of 22. So that's 1 times 22, or 22 over 5. We can turn that back into a mixed number, because 22 divided by 5 is 4 remainder 2, the denominator stays the same, and then we can check 4 times 5 is 20, plus 2 is 22. So let's look back to this first question, where we needed to find 1/5 of 13. We can show a fraction bar split into fifths, and because we're finding 1/5, we can shade one of those fifths. Now, we can share out 10 blocks with 2 blocks in each of our fifths, so that's why 2 is our whole number. But then, because we're finding a fifth, we can split each of our remaining blocks into fifths and share those out. We can do the same with this block and with this one. So then, when we look at our fifth, we have 2 wholes and 3/5, so that's our answer. Then we needed to find 1/4 of 17, so we can show a fraction bar split into quarters, and we're finding 1/4. we can share out 16 blocks with 4 in each group, so 4 is our whole number, and then we can split this remaining block into quarters because we're finding 1/4. So with those 4 quarters, if we share those out, we have 1/4 in each group, so that gives us 4 and 1/4 as our answer. Then we had 1/5 of 22, so we can show 1/5 on our fraction bar. We can share out 20 of the blocks to give us 4 blocks in each of our fifths, and then, because we're finding 1/5, we can turn each of our remaining blocks into 5/5 and share them out. That means that we have 4 wholes and 2/5 in each of our fifths, so that's 4 and 2/5 as our answer. Now we're finding a fraction of a number, and we know that to find a fraction of a number, we can divide by the denominator and then multiply by the numerator. But here, because we're finding 3/4 of 21, when we divide 21 by 4, we're going to get a remainder or a mixed number. So we need to use a slightly different method here. To find 3/4 of 21, we can represent that as 3 times 21 over 4. Now 3 times 21 is 63, so we can show 63 over 4 as an improper fraction. And to turn it back into a mixed number, we can divide 63 by 4. 6 divided by 4 is 1 remainder 2, because 1 times 4 is 4, plus 2 is 6. And 23 divided by 4 is 5 remainder 3. So we can write the remainder 3 as our numerator, and the denominator is the divisor. So our answer is 15 and 3/4. So what we really did here was multiply 21 by 3. So multiply by the numerator first, and that gave us 63. And then we divided by 4. We just represented the division here as an improper fraction. Now we need to find 2/5 of 23. So we can write that out as 2 times 23 over 5, because we're going to multiply by the numerator and then divide by the denominator to get a mixed number as our answer. So 2 times 23 is 46, so we can show the division as an improper fraction, 46 over 5. Now 46 divided by 5 is 9 remainder 1, and the denominator stays the same. And we can check 9 times 5 is 45, plus 1 is 46, so our answer is 9 and 1/5. Now we need to find 2/3 of 17. We can show that as 2 times 17 over 3. To work out 17 times 2, we can use short multiplication. 7 times 2 is 14, so 1/4, and 1 times 2 is 2, plus 1 is 3. So that's 34 over 3. To get our mixed number answer, we can divide 34 by 3, and that gives us 11 remainder 1, so our answer is 11 and 1/3. Let's look back to this first question, where we needed to find 3/4 of 21. We can show a fraction bar split into quarters, and because we need 3/4, we can shade 3 of those fraction bars. Now we can share out 20 of these blocks, with 5 blocks in each of our quarter, so altogether in what we've shaded we have 5, 10, 15 blocks. Then with this remaining block, because we're finding quarters, we can split it into quarters and then share out 1/4 in each of our quarters. So we have 1, 2, 3/4 in what we've shaded, so that's why we have 3/4 in our answer. Then we needed to find 2/5 of 23, so we can show a fraction bar split into fifths, and we want 2/5. Now we can share out 20 of these blocks, with 4 blocks in each of our fifths, and with these 3 remaining blocks we can split them into fifths and share them out. So now we have 4 blocks and 3 fifths in each of our fifths. But remember, we were finding 2 fifths. So in the 2 fifths, we have 8 whole blocks and 6 fifths. But we can't write 8 and 6 fifths as our answer because we can't have an improper fraction in a mixed number. But we know that 5 fifths is the same as 1 whole. So we can show 1 whole instead of 5 fifths. And now, in the 2 fifths that we have shaded, we have 9 blocks and 1 fifth of another one. So that's 9 and 1 fifth as our answer. Now we need to multiply a fraction by a whole number. And the main thing to remember here is that we only multiply the numerator by the whole number, not the denominator. So first we have 3/4 times 5. So we can show that as 3 times 5 over 4 because we're only multiplying the numerator and the denominator stays the same. So 3 times 5 is 15, the denominator stays the same. So as an improper fraction, we have 15/4. But we can turn that into a mixed number by dividing. 15 divided by 4 is 3, remainder 3, and the denominator stays the same. So our answer is 3 3/4. And we can check 3 times 4 is 12, plus 3 is 15. Now we have 2/3 times 6. So if we're using the same method, we can write that out as 2 times 6 over 3. 2 times 6 is 12, and the denominator stays the same. So we have the improper fraction 12/3. 12 divided by 3 is exactly 4, so that's our answer. Now for this question, there was a slightly quicker method that we could have used. Times and of mean the same thing. So if we were finding 2/3 of 6, we could divide 6 by the denominator, and 6 divided by 3 is 2, and then we could multiply by the numerator, and 2 times 2 is 4. For this question, for this first question, it wouldn't have worked because 5 divided by 4 would give us a remainder or a mixed number. So here we needed to multiply by the numerator first. But let's use fraction bars to show what we did. 3/4 we started with, and we were multiplying by 5, so we can show 3/4 5 times. If we do some regrouping here, we can see that we have 15/4, but we've got 3 whole bars shaded in and 3/4 of another one, so that's why our answer is 3 3/4. Then we had 2/3 times 6, so we can show 2/3 6 times. We can see that that gives us 12/3, but if we do some regrouping, we can fill up 4 whole fraction bars, so our answer is just 4. Now let's multiply a mixed number by a whole number. So we have 2 3/4 times 3. Now the way I like to do this is to look at the mixed number and first multiply the whole number part of the mixed number, so work out 2 times 3, then multiply the fraction part of the mixed number, so work out 3/4 times 3, and then add up the answers. So if we look at the whole number first, 2 times 3 is 6, so then we can work out 3/4 times 3 and add up our answers. But we need to be really careful here. When we multiply a fraction by a whole number, we only multiply the numerator and the denominator stays the same. We'll see why we have to do that in a moment. But 3 times 3 is 9 and the denominator stays the same, so we have 9 over 4. But that's an improper fraction. We have a numerator which is larger than the denominator. So we can't write 6 9/4 as our answer because we can't have an improper fraction in a mixed number. We can't have a fraction where the numerator is larger than the denominator if we have a mixed number. But we can change 9 quarters to a mixed number. A fraction is really a division, so we can divide 9 by 4. That's 2 remainder 1, because 2 times 4 is 8, and then we need 1 more to get to 9. So notice the 1, the remainder, is written as the numerator, and the denominator stays the same. So 3 quarters times 3 is 2 and 1 quarter. So now remember the last step was just to add up our answers. So we've multiplied 2 by 3, we've multiplied 3 quarters by 3, so we need to add 6 and 2 1/4. 6 plus 2 is 8, and the quarter stays the same, so our answer is 8 and 1/4. Now let's try 2 and 1/4 times 6. Remember, we can multiply the whole number part of the mixed number first, then multiply the fraction part, then add up our answers. So 2 times 6 is 12, so we can work out 1/4 times 6 and then add up our answers. Again, remember, when we're multiplying a fraction by a whole number, we only multiply the numerator and the denominator stays the same. So 1 times 6 is 6, the denominator stays at 4, but now we have 6 quarters. Again, we've got the same problem. We can't write 12 and 6 quarters as our answer because we can't have an improper fraction. We can't have a fraction where the numerator is larger than the denominator if we're writing our answer as a mixed number. But we can change 6 quarters back into a mixed number by dividing. 6 divided by 4 is 1 remainder 2. So the remainder 2 is our numerator. And that's because 1 times 4 is 4, and then we need 2 more to get to 6. The denominator stays the same, so we worked out that 2 times 6 is 12, 1/4 times 6 is 1 and 2 quarters, so now we can add 12 and 1 and 2 quarters. 12 plus 1 is 13, the 2 quarters stays the same, so our answer is 13 and 2 quarters. But now, let's think about why this method works, why we can split the mixed number up and multiply the whole number and then the fraction and then add up our answers. So let's take the first question, 2 and 3/4 times 3. We worked out that 2 times 3 is 6, 3/4 times 3 is 9 quarters, which is 2 and 1/4, and then we added 6 and 2 1/4 to get our answer. But let's think about what multiplying a mixed number is really about. To show 2 and 3/4, we can show 2 whole bars and then 3/4 of another one. We're multiplying by 3, so we can show 2 and 3/4 3 times. So how does that give us 8 and 1/4? Well, look at the whole numbers. We've got 6 whole fraction bars, so that's our 6. And then, remember, each of these sections is a quarter, and altogether we've got 3, 6, 9 quarters. So that's our 9 quarters. But look what we can do. We can regroup. We can regroup that 9 quarters into 2 wholes, and 1/4. So that's why dividing the numerator by the denominator changes it back into a mixed number. So you can see now, what do we have all together? We have 8 wholes, 6 up here, and then 2 here, which matches the 6 and 2 we have here, and we have 1/4. So our answer is 8 and 1/4. Now, let's try the other question we looked at. That was 2 and 1/4 times 6. So we did 2 times 6 to get 12, and we did 1/4 times 6 to get 1 and 2/4, and then we added up our answers to get 13 and 2/4. But let's think about what this multiplication is really telling us. We have 2 and 1/4, so there's 2 wholes and 1/4 of another fraction bar, and this time we're multiplying by 6, So we need to show 2 and 1/4 6 times. There we've got 2 and 1/4, 1, 2, 3, 4, 5, 6 times. So you can see how our working out matches. We did 2 times 6 to get 12, and we have 12 full fraction bars here. Then we did 1/4 times 6 to get 6/4. Remember, each of these parts is 1/4, and we have 6 of them, so we have 6/4. But remember, we divided 6 by 4, and that gave us 1 remainder 2, so 1 and 2/4. And you can see, if we regroup these fraction parts, we now have lots of empty bars, which we can just ignore. But for this first bar, the whole bar is shaded, so we have an extra 1 whole, and we have 2/4 of another. So altogether, we have 13 and 2/4. 13 because we have 12 here and 1 here, and we have our 2/4. Now notice, 2/4 is the same as 1/2. If we keep the same amount of the fraction bar shaded, but just divide it into 2 pieces rather than 4, you can see that 2/4 is the same as 1/2. So sometimes you can simplify your fraction. So we could have written 13 and 1/2 instead of 13 and 2/4. But most of the time, you'll still get the mark if you leave the fraction unsimplified. Now 1 and 1/3 times 60. So we can follow the same steps. Do 1 times 60, do 1/3 times 60, and then add up our answers. So 1 times 60 is of course 60, and with 1/3 times 60, we have to remember to only multiply the numerator by 60. So 1 times 60 is 60, the denominator stays the same, so we have 60/3. Remember, this is an improper fraction, but we can change an improper fraction back into a mixed number by dividing. Now 60 divided by 3 is 20. You might need to use short division here, or you might be able to do it mentally. 6 divided by 3 is 2, 0 divided by 3 is 0. So we've worked out 1 times 60, we've worked out 1/3 times 60, so we just add up our answers. And 60 plus 20 is 80, so that's our answer. So notice sometimes when you multiply a mixed number by a whole number, you still get a whole number as your answer. And we have that because 60 divided by 3 was exactly 20 with no remainder. Now 13 times 1.5. So 13 times 1 is 13, and we can work out 13 times 1/2, or 1/2 times 13. We remember the denominator stays the same, and 1 times 13 is 13, so we have 13 halves. But we can change that back into a mixed number by dividing. 13 divided by 2 is 6 remainder 1, because 6 times 2 is 12, and we need 1 more to get to 13. The denominator stays the same, so now we just add up our answers and work out 13 plus 6.5. The half stays the same, 3 plus 6 is 9, 1 plus nothing is 1, so our answer is 19.5.